Hello students, today we are going to solve few questions on permutations and combinations. So first of all, what is permutation? Permutation is defined as arrangement of R things that can be done out of total N things, right? So permutation is an arrangement of R things that can be done out of N things. So the formula for permutation is NPR is equal to factorial N divided by factorial N minus R, right? Whereas combination is defined as, so it's a selection of R things, right? Whereas permutation is defined as arrangement of R things, right? So combination is defined as selection of R things that can be done out of total N things, right? So that can be done out of N things. So formula for combination is NCR is equal to factorial N divided by factorial R into factorial N minus R, right? Here, so the given question is based on combination. So let us read the question. If there are 14 books on a shelf, in how many ways can 5 of them be selected? So out of 14 books, so we have to select 5 books. In how many ways 5 books can be selected? Right? So that is called combinations. So it is selection of R things. Here R things is nothing but 5 books. A selection of 5 books out of total N things. So N is nothing but 14. Right? Therefore, NCR is equal to, using this formula, NCR is nothing but 14C5, right? Is equal to factorial N. So which is factorial 14 divided by factorial R is factorial 5 into N minus R factorial, this formula. So N is 14 minus 5 factorial, right? Simplify it. So 14 factorial is 14 into 13 into 12 into 11, so on up to 2 into 1, right? Divided by 5 factorial. 5 into 4 into 3 into 2 into 1 into 14 minus 5 is 9. So which is 9 factorial. So which is nothing but 9 into 8 into 7, so on up to 2 into 1. Right? So in the numerator, starting from 9, right? So if you consider 10 into 9, so can cancel 9 factorial. Right? 9 factorial and 9 factorial in the denominator. So we'll cancel this part, right? And also we have 14 into 13 into 12 into 11 into 10 in the numerator and 5 factorial, which is 5 into 4 into 3 into 2 into 1 in the denominator, right? So 2 into 5, so we can cancel 5 and 5. And 3 into 4 is 12, so we can cancel 4 and 4, right? Therefore, so at last we have 14 into 13 into 11. So multiply these numbers. So 14 into 11 is, so 154 into 13. So 1352. 13 into 452. 65, 70. Then 13 into 1, 13 plus 7, 20. So 2002 is the right answer. Right? So in 2002 ways, option A is the right answer, right? So 5 books can be selected in 2002 ways, right? Therefore, option A is the right answer. Students, if you want to practice such type of questions on permutations and combinations and also on many more topics, so please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 2. A boy has 3 library tickets and 8 books of his interest are there in the library. Out of these 8, he does not want to borrow chemistry part 2 unless chemistry part 1 is also borrowed. The number of ways in which he can choose the 3 books to be borrowed is. So here, out of 8 books, boy has to borrow three books because he has 3 library tickets. So let us imagine 8 books. So 3, 4, 5, 6, 7, 8 books, right? So in that, chemistry part 2 and part 1, these 2 books are also there, and it is given that he does not want to borrow chemistry part 2 unless part 1 is also borrowed, right? And he has 3 tickets, 3 library tickets. That means he has to borrow 3 books in that, right? So just imagine chemistry part 2 book is borrowed, right? It is understood that chemistry part 1 book is already borrowed, right? Unless chemistry part 2 is borrowed, part 1 is borrowed, he cannot choose chemistry part 2, right? If part 2 is borrowed, let us consider case 1, right? Chemistry part 2 is borrowed. So it is understood that, right, part 1 is also borrowed. Part 1 is also borrowed. Therefore, so he has selected already 2 books. Selected 2 books. So in the remaining 6 books, in the remaining books are 6. Remaining books are 6. In that, he has to select 1 book. Has to select 1 book. 1 book. So, in how many ways he can select 1 book in the remaining 6 books? Remaining books are 6. In how many ways he can select 6 books? In 6 different ways. So, he can select first book or second book or third, fourth, fifth or sixth book. In 6 different ways, he can select 1 book out of 6. That is nothing but, so in 6C1 ways, he can select 1 book, right? So in 6C1 ways, whereas, so in first case, so chemistry 1 is borrowed means chemistry 2 is borrowed means part 1 is also borrowed. That means in only 1 way, he can borrow chemistry part 1 and part 2. This is the only choice, right? Therefore, number of ways in which he can borrow chemistry part 2. We are focusing on part 2 only, right? Number of ways in which chemistry part 2 can be borrowed is only 1 way. 1 way, right? So you can, either he can choose part 2 or not, right? That is the only choice, right? So in only 1 way, he can borrow chemistry part 2. So it is understood that part 1 is also borrowed. Therefore, total number of books becomes 3 and number of ways, total number of ways of selecting 3 books. Total number of ways of selecting how many books? 3 books is equal to, right, number of ways of selecting 2 books in which chemistry part 2 is included, right, is 1 way into number of ways of selecting 1 book out of 6 remaining books is 6C1 ways. 6C1 ways, right? So 6C1 is nothing but 6 into 1 is 6 ways. In 6 ways, the boy can select 3 books in which chemistry part 2 is included, right? So we'll consider the second case in which part 2 is not borrowed, right? So when chemistry 2 is not borrowed, right? So in chemistry part 2 is not borrowed, right? So he can borrow chemistry part 1. There is no restriction that he cannot borrow part 1, right? Unless he reads part 2. There is no rule such as such, right? Therefore, he can borrow chemistry part 1. Therefore, remaining books are 7, right? Right? When part 2 is not borrowed, remaining books are 7. In that, he has to select. He has to select how many books? 3, right? So, has to select 3 books. Therefore, ways of or number of ways of selecting 3 books. Selecting 3 books out of 7, right, is equal to 7C3, right? So, 7C3 ways. Therefore, so by combining first and second cases, when chemistry part 2 is not borrowed and when it is borrowed, combining these 2 cases, so total number of ways, right? Total number of ways of selecting 3 books. So in first case, number of ways are 6 ways, right? So 6 plus in the second case, 7C3 ways, right? So in 7C3 ways, a boy can select 3 books. So 6 plus 7C3 means 7 factorial by 3 factorial into 7 minus 3 factorial, right? So we are using n factorial by r factorial into n minus r factorial is equal to NCR, right? Therefore, 6 plus factorial 7 means 7 into 6 into 5 into 4 and it continues up to 1. So we'll stop here only, 4 factorial. Instead of writing 4 into 3 into 2 into 1, we are writing 4 factorial. So divided by 3 factorial into 4 factorial. So that you can cancel 4 factorial and factorial 4. So it becomes 6 plus 7 into 6 into 5 divided by 3 factorial is 6. So that we can cancel 6 and 6. 7 into 5, which is 35. So 35 plus 6 is 41, right? Therefore, in 41 ways, boy can select 3 books, right? In 3 library tickets, he can select 3 books out of 8 books, right? Out of 8 books, he can select 3 books in 41 ways, right? Here, the condition is, so he cannot borrow chemistry part 2 book unless chemistry 1 is also borrowed, right? Therefore, the answer for the given question is 41, option B. Question number 3. In how many ways can 4 coins be put into 3 piggy banks when each piggy bank can take any number of coins? So we'll consider 4 coins, students, and 3 piggy banks, right, like this. So here, each coin has 3 possibilities or 3 ways of being placed in the piggy banks, right? So we'll consider the first coin. So it has 3 possibilities of being placed in 3 piggy banks, right? Therefore, so here are 4 coins, right? Therefore, so the ways in which the 4 coins be put into 3 piggy banks are, so 3 raised to 4 ways. In 3 raised to 4 ways, we can put 4 coins in 3 piggy banks such that, so each piggy bank can take any number of coins, right? Even you can put only 1 coin in each piggy bank or 2 coins or 3 coins or 4 coins, right? Therefore, there are 3 raised to 4 ways. Here 4 is nothing but number of coins and 3 is nothing but number of piggy banks, right? So 3 raised to 4 ways means 3 into 3 into 3 into 3, which is 9 into 3, 27 into 3, 81. There are 81 ways. So to put these coins in 3 piggy banks such that each piggy bank can take any number of coins, right? So option A is the right answer. Question number 4. The straight lines I1, I2, I3 are parallel and lie in the same plane. Total number of m points are taken on I1 and n points on I2 and k points on I3. The maximum number of triangles formed with vertices at these points are. So students, let us consider three parallel lines in the same plane. So I1, I2 and I3. I1, I2 and I3. Right? These are the three lines. And total number of m points are taken on I1. We'll consider m points. That means m number of points. So 1, 2, 3, 4, so on up to m points. Right? And total number of n points on I2. So we'll consider A, B, then C, so on up to n points. Right? And k points on I3. So we'll consider capital A, B, C, so on up to K points on I3, right? Here the question is maximum number of triangles formed with vertices at these points. So here on joining three vertices, so you will get a triangle, right? So that means to form a triangle, we need 3 points, right? How many triangles can be formed using 3 points, right? So out of m, n and k, right? Here total number of points is equal to m plus n plus k. So total number of points is equal to m plus n plus k. Therefore, possible ways of joining 3 points. I'm not telling it is particularly the triangle. You can join 3 points in any way, right? You can, for example, so 1, 2, 3, for example, right? 3 points lie on the same plane. But we have joined 3 points here, right? So there are many ways to join 3 points, right? So possible ways of joining 3 points. Possible ways of joining 3 points is equal to, so m plus n plus k, total number of points, C3. Because we are joining 3 points here, therefore NCR is nothing but m plus n plus k, total number of points. In that we have to join 3 points, right? So m plus n plus k, C3 gives ways of joining 3 points, right? So in that, ways of joining 3 points in a same line, right? Right? So ways of joining 3 points on a same line, is equal to on I1 line, first line, right? So we can join 3 points in MC3 ways, right? So number of ways in which we can join 3 points is MC3. Here M means total number of points, right? Total number of points in I1. In that we have to join 3 points. The ways of joining 3 points is equal to MC3, right? So on first line I1 and NC3, total number of points on second line is equal to N. C3 gives ways of joining 3 points on a same line. So KC3 on a same line, right? So which doesn't form a triangle? Which doesn't form a triangle, right? So these ways, they do not form a triangle. They just give a straight line, right? If you join 1, 2, 3, you will get a straight line. If you join ACD, small ACD, you will get a straight line, right? So these are the ways in which the triangle cannot be formed. Therefore, ways of forming a triangle by joining 3 points. By joining 3 points is equal to, so in first way, right, which we have taken m plus n plus k C3 in first way. So this first way shows all the possible ways of joining 3 points, including joining 3 points on a same line, right? Therefore, so all the ways of joining 3 points, m plus n plus k c3 minus joining 3 points on a same line, right? So which is mc3 plus, so in the bracket we'll have to consider nc3 plus kc3. These are the ways. So on simplification, you will get m plus n plus kc3 minus mc3 minus nc3 minus kc3, right? So these are the ways of forming a triangle by joining 3 points. So look at the options. Option B is the right answer. Question number 5. Let A be a set containing 10 distinct elements. Then the total number of distinct functions from A to A. So we'll consider set A here, right? So it contains 10 distinct elements. So let A1 be one of the elements, first element. And the second element be A2, A3 be the third element. So up to A10, right? These are the elements of set A. So here total number of distinct functions from A to A. So that means we'll consider a function, right? F of AM is equal to an because the function is a to a. So f of am is equal to an. That means if you consider f of a1, right, this will be equal to, so one of the elements in the given set. So it may be a7 or a2 or a3, right, any number, such that f of am is equal to an, right, where m and n, so m ranges from 0 to, not 0, it is 1 to 10, because there are 10 elements in the given set and these elements are distinct elements. So the elements are not equal to each other, right? They are distinct elements. So here m ranges from 1 to 10 and also n ranges from 1 to 10, such that f of am is equal to an, right, which belongs to set of A, right? Here the question is the total number of distinct functions from A to A is. So if you consider f of A1, right, so is equal to A3. So for f of A1, so f of A1 can be equal to A2 also, right? F of A1 can be equal to even A1 itself. F of A1 can be equal to A4, right? So like that, f of A1 can be equal to A10, A10, right? Therefore, there are 10 possibilities. 10 possibilities for f of A1, right? 10 possibilities for f of A1, right? In the same way, for f of A2 also, there are 10 possibilities. 10 possibilities, right? So for f of A3, there are 10 possibilities, right? Up to f of A10, there will be 10 possibilities, right? So here the question is total number of distinct functions from A to A. Therefore, total number of distinct functions are product of all these possibilities, right? So total number of distinct functions from A to A, is equal to, so product of all these possibilities. So 4, 5, 6, 7, 8, 9, 10 times 10, right? Which is 10 raised to 10, right? 10 raised to 10. 10 is the total number of distinct functions from A to A, right? So here f of A2 can be equal to A1 or A2 or A3, so on up to A10, right? So therefore, so it can be product of these two also, right? Therefore, so total number of possibilities are 10 raised to 10. Option B is the right answer. Question number 6. A candidate is required to answer 7 questions out of 12 questions, which are divided into 2 groups, each containing 6 questions. Each group containing 6 questions, right? He is not permitted to attempt more than 5 questions from each group. The number of ways in which he can choose 7 questions is, here students, 12 questions are divided into 2 groups. So we'll consider group A and group B. Group A contains 6 questions, right? Whereas group B contains 6 questions. 6 questions, right? In which the candidate has to attempt maximum 5 questions, not more than 5 questions, right? Therefore, so we'll consider group A, so that candidate can attempt 5 questions from group A, or he can attempt 4 questions, or he can attempt 3 questions, or he can attempt 2 questions, right? Therefore, so number of questions can be attempted are 5, 4, 3 or 2 number of questions from group A, so that group B, in which the questions can be attempted, will be 2, 3, 4 and 5, so that the total questions attempted will be 7, right? In each case, the total questions attempted will be 7, right? It is given that the candidate has to answer 7 questions out of 12 questions, right? Now let us consider ways of choosing these questions or answering these questions, right? So out of 6 questions, candidate can answer 5 questions, right? In first case, he can answer 5 questions. So we'll consider 6 questions. For example, so there are 6 questions in group A, 1, 2, 3, 4, 5, 6. He has to answer 5 questions according to first case, right? So he can choose 1, 2, 3, 4, 5 continuous questions, right? This is the one way. Or he can choose 2, 3, 4, 5, 6, another way. Or he can choose 3, 4, 5, 6, 1. 3, 4, 5, 6, 1, another way. Or he can choose 4, 5, 6, 1, 2. This is another way. Or 5, 6, 1, 2, 3. Another way. Or 6, 1, 2, 3, 4. Right? These are the ways of answering 5 questions. Right? In first case. Therefore, so this is equal to ways of answering 5 questions. This is not number of questions answered. It is ways of answering. Ways of answering. Here totally he has to answer 7 questions. We'll consider ways of answering 7 questions is equal to ways of answering 5 questions according to first case, plus ways of answering two questions out of 6 questions. So which is equal to, so 5C6 plus 2, sorry, not 5C6, 6C5 plus 6C2, right? Here, so in first case, so he can go for 6 different ways to choose 5 questions or to answer 5 questions. The 6 is nothing but, so it is equal to 6C5, right? So there are 6C5 ways of choosing 5 questions or answering 5 questions. And also in the first case of group B, right? So he has to choose 2 questions. So how many ways? In how many ways he can choose 2 questions? In 6C2 ways, right? So again, we'll consider 6 questions. 1, 2, 3, 4, 5, 6, right? So he can choose 1 and 2, right? Or he can choose 2 and 3, 3 and 4, 4 and 5, like that. So he can choose 6C2 ways, right? In 6C2 ways, which is equal to 6 factorial divided by 2 factorial into 6 minus 2 factorial, right? Which is equal to, so 6 factorial by 2 factorial into 4 factorial. So 6 into 5, here into 4 into 3 into 2 into 1 will get cancelled by 4 factorial. Divided by 2 into 1, you will get 15. In 15 ways, he can choose 2 questions out of 6 questions, right? Therefore, it is 6C2 plus 6C5, right? Which is equal to 6, since 6C5 is 6, 6C2 is 15 into 15, not plus, it is into 15. So there are 90 ways to choose 7 questions out of 12 questions, right? Now, in the second case, he has to choose 4 questions, right? Out of 6 questions, there are 6C 4 ways to choose 4 questions into 6C 3 ways to choose 3 questions from group B, which is equal to, so just simplify 6C4. So 6C4 is 6 factorial by 4 factorial into 6 minus 4 is 2 factorial. So which is 6 into 5 by 2, right? So you will get 15, right? So 6C4 is 15 into 6C3. So what's the value of 6C3? So 6 factorial divided by 3 factorial into 6 minus 3 is 3 again. So 3 factorial and 3 into 2 into 1 in 6 factorial will get cancelled. We have 6 into 5 into 4 by 3 factorial, which is 3 into 2 into 1. So 2 into 2 and 3 into 2. So 20. So 15 into 20 is equal to 300. There are 300 ways, right, to choose 7 questions in the second case. And also, so in the third case, so out of 6, the person has to choose 3 questions. There are 6C3 ways to choose 3 questions into 6C4 ways to choose 4 questions. So both are same. Second case and third case will be same. So which is 20 into 15, again it is 300. And in the fourth case, the person can choose 2 questions in 6C2 ways into 6C5 case, right, from group B. So same as in the first case, here also there are 90 ways to choose 7 questions, both from A and B, together from A and B, right? Here the question is the number of ways in which he can choose 7 questions. Add these numbers. So total number of ways to choose 7 questions is equal to, in first case, the person has 90 ways to choose 7 questions. In second and third case, he has 300 and 300 ways to choose 7 questions. And in the last case, he has 90 ways. So together it is 780 ways to choose 7 questions, right? There are 780 ways to choose only 7 questions out of 12 questions, right? Here the condition is from each group, person can attempt a maximum of 5 questions from each group, right? Therefore, option A is the right answer. Question number 7. In how many ways can 7 colors be chosen for a painting from a set of 24 colors? So from 24 colors, we have to choose 7 colors. In any order you can choose, because in combinations, so the order doesn't matter, right? So in combinations, so one of the several ways of combination is nothing but one of the several ways of choosing items from a large set of numbers. From a set of numbers that is 24 colors, so we have to choose 7 colors, right? Without considering an order. Whereas in permutations, we have to consider the order, right? So here arranging a set of objects into sequential order are termed as permutation. Here in combination, so no need to follow any order. Just we have to choose 7 colors. That's it, right? So in how many ways the 7 colors can be chosen out of 24 colors, which is nothing but NCR is equal to factorial n divided by n minus r factorial into r factorial. Here n is total number of colors, which is 24. C R is nothing but number of colors to be chosen, right? So to be chosen is 7. So here factorial 24 divided by 24 minus 7 factorial into 7 factorial. So simplify it. 24 into 23 into 22 into so on up to. So you can consider 19 into 18 into 17 into 16. So on up to 2 into 1 is 24 factorial divided by. So 7 factorial. This term is 7 into 6 into 5 into 4 into 3 into 2 into 1 into 24 minus 7 is 17 into 16 into so on up to 2 into 1. Right? So here students, we can cancel 17 factorial part. 17 factorial part. Right? So considering the numerator and denominator, here start from 18, right? 19 into 18. So 2 into 9 is 18. Then 3 into 3 is 9. And here we have, so 4 into 6. 6 and 6 will get cancelled. Then we have 23 into 22 into 21 into 20 into 19. And we have 1 3 here. 19 into 3 whole divided by 7. Right? So 7 into 5. We have 5 here. So 7 into 3 is 21 and 5 into 4 is 20. Therefore, finally, we have 23 into 22 into 3 into 4 into 19 into 3. Right? Simplify it, you will get the answer. So 23 into 22 into 3 into 4 into 19 into 3 is equal to 3,46,104. Right? So in 3,46,104 ways, we can choose 7 colors out of 24 colors. Right? So get the options. Option C is the right answer. Question number 8. A box contains 2 white, 3 red and 4 black balls. If at least one red ball is to be included in the draw, the number of ways of drawing 3 balls is given by. All balls are considered to be different. So here students, in a box, so box contains 2 white balls, 3 red balls and 4 black balls. Right? So we have to draw 3 balls from the box such that at least one ball should be a red ball. Right? So here the red balls are 3. In a box there are 3 red balls and the remaining balls are white and black. Right? So there are 6 balls remaining. Right? In that we can draw all 3 balls. Right? So all 3 balls, or we can draw only 2 balls while drawing 2 red balls. Right? I'm focusing on red balls. Right? Or we can draw only 1 red ball. Right? So if we have already drawn 3 balls, so what is the remaining ball to be drawn? 0, because totally we have to draw 3 balls. Right? So when 2 red balls are drawn, the remaining ball to be drawn is only 1. If one ball drawn is red one, the remaining ball to be drawn is equal to 2. Right? Therefore, we'll consider ways of drawing 3 balls. Ways of drawing 3 balls is equal to, so out of 3 red balls, if we have drawn 3, all 3 red balls, therefore 3C3, there are 3C3 ways of drawing red balls. That means 3C3. What is the value of 3C3? So 3C3 value is NCR is factorial divided by R factorial into N minus R factorial. Right? Therefore, there are 3C3 plus, there is no remaining 0 balls, so no need of drawing ball from the next white and black balls. So there are 3 ways. 3C3 is equal to only 1. right? So there is only one way of drawing three balls, right? For example, there are three balls. If we have drawn all the three balls, this is the only way to draw all three balls, right? There is only one way to draw three balls from three red balls. So in the second case, when two balls are red, right? Ways of drawing three balls is, so out of three red balls, if two balls have been drawn, right? There are two ways of drawing two red balls, right? Into, in the remaining six balls, one ball should be drawn. The ways of drawing one ball is 6C1, right? 6C1. So for example, 1, 2, 3, 4, 5, 6. Either you can choose first one, right? There are many ways, or second one, or third one, or fourth one, or fifth one, or sixth one, right? That means there are six ways to draw a single ball out of six balls, right? Therefore, 6C1 is nothing but 6 itself, whereas 3C2, what is the value of 3C2? So factorial 3 divided by factorial 2 into 3 minus 2 factorial, which is equal to 3 into 6C1 is equal to 6. Therefore, there are 18 ways to draw 3 balls, such that 2 balls are red and 1 ball is the remaining ball. It may be white or black, right? And in the third case, if one ball drawn is red, right? So out of three balls, three red balls, so we can choose first ball or second ball or third ball. There are three ways, right? If you consider the formula, it is 3C1, right? 3C1 is nothing but 3 itself into, so out of 6 balls, 1, 2, 3, 4, 5, 6, we have to choose 2, either first and second, or second and third, or third and fourth. There are many ways. There are 6C2 ways, right, of drawing only 2 balls. 6C2 is nothing but factorial 6 divided by 2 factorial into 6 minus 2 factorial, which is 4 factorial, which is 6 into 5 by 2, which is 15, right? So therefore, 6C2, right? 6C2 into 3C1. So 3C1 is 3 itself into 6C2 is 15. There are 45 ways of drawing 3 balls, such that 1 ball is red, remaining 2 balls may be white or black, right? So the question is, so the total number of ways of drawing 2 balls, not 2 balls, 3 balls, right? Totally, there are 1 plus 18 plus 45 ways of drawing 3 balls. 18 plus 1 is 19, 19 plus 45 is 64. There are 64 ways of drawing 3 balls. Hence, option B is the right answer. Question number 9. There are 10 people named A, B, C, D, E, F, G, H, I, and J. We have the capacity to accommodate only 5. In how many ways can we arrange them in a line? If A is must and G and H must not be included in the team of 5. Here, students, out of 10 people, so A to J, G and H must not be included in the team of 5, right? We have to select only 5 people. In how many ways the 5 people, the arrangement of 5 people can be possible, right? So given that G and H must not be included, that means included people are, so here A is must, right? So here we'll consider A is must, and the remaining people are B, C, D, E, F, I, and J, right? These 7 people, so we have to arrange these 7 people, right? So out of 7, we have to choose only 4 people, right? Because we have the capacity to accommodate only 5. In that, A is must, one person is must, right? Therefore, we have to choose remaining 4 people out of 7 people, B, C, D, E, F, I, and J, right? In how many ways these 4 persons can be chosen, right? In how many ways? So ways of choosing 4 persons out of 7. is nothing but 7C4. In 7C4 ways, we can choose 4 persons, right? Whereas, so what is 7C4? So you can simplify it by using NCR formula, or you can leave as it is, 7C4 ways, right? Since A is must, one person is must. Just imagine there are 1, 2, 3, 4, 5, 6, 7 people, and A is must. This person is A, right? So these are the persons B, C, D, E, F, I, and J. These are the 7 persons, right? You can choose B, C, D, E along with A, right? So I'll just write the combinations B, C, D, E plus A, or you can choose C, D, E, F plus A, or you can choose D, E, F, I plus A, right? Or you can choose E, F, I, J plus A, right? So in this way, you can choose A in many ways, right? Therefore, the ways in which A can be added, the person A can be added to remaining 4 persons is 5 factorial times. 5 factorial, right? So the person A can be added to the remaining persons in 5 factorial times. Therefore, total ways of selecting 5 persons out of 10 persons, right? Total ways of selecting 5 persons is equal to, so 5 factorial into 7C4, right? 5 factorial into 7C4. So 5 factorial is nothing but number of ways in which person A can be added to remaining 4 persons, or A can be arranged, right? So, to the remaining 4 persons into number of ways of choosing 4 persons, right? So out of 7 persons is 7C4. Therefore, for the given question, in how many ways can we arrange them in a line if A is must and G and H must not be included in the team of 5? So in 5 factorial into 7C4. So out of 4 options, 5 factorial into 7C3 is given. Right? Here 7C4 is equal to 7C3. We all know that. Because, so apply the formula NCR is N factorial, which is 7 factorial, divided by R factorial into N minus R factorial. Here R is 4. So it is nothing but 7 factorial divided by 4 factorial into factorial 3, which is equal to 7C3. 7C3 is nothing but 7 factorial divided by 3 factorial into 7 minus 3 factorial, which is nothing but 7 factorial by 3 factorial into 4 factorial. Both are same. Therefore, in place of 7C4, can we write 7C3? Yes, both are same. Therefore, in 5 factorial into 7C3 factorial ways, 5 persons can be arranged, right? In a line. Therefore, option D is the right answer. Question number 10. A 5-digit number divisible by 3 is to be formed using the numbers 0, 1, 2, 3, 4, and 5 without repetitions. The total number of ways this can be done is. Here, students, we have to form a 5-digit number, right? So, 5-digit number which is divisible by 3. That means in a number, when sum of the digits is equal to 3 or the sum is multiple of 3, right? Which is nothing but when it is divisible by 3, then the number is divisible by 3, right? For example, so 2300, so we'll consider 5-digit number 23415, 23,415. Right. So the sum of the digits is 2 plus 3, 5, 5 plus 4, 9, 9 plus 6, 15. Right. Here 15 should be divisible by 3. It is divisible by 3. Therefore, the number 23,415 is divisible by 3. This is how it goes. Right. So here in the given question, we have to form a 5-digit number which is divisible by 3. Right. Here are 6 values given, including 0. Right. There are 6 values. So we have to choose only 5 values to make a 5-digit number. right? For that, let us consider the sum of these 6 values so that we can decide which value should be neglected here, right? So here sum of 6 values, sum of the given values is equal to 0 plus 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15. Here, sum of the given values is equal to 15, which is a multiple of 3, which is divisible by 3, right? Therefore, we have to decide which value should be neglected here, right? Either 0 or 3 can be neglected. So that 15 minus 0 becomes, if you avoid 0, it becomes 15, right? So sum of the values becomes 15 again, which is divisible by 3. And also 15 minus 3. If you neglect 3, the value becomes, or sum of the values becomes 12, which is again divisible by 3, right? Therefore, there are two methods to solve this, right? In two ways, you can solve this. So that means neglecting 0. Neglecting 0, right? So the numbers can be found using the remaining numbers, right? So remaining numbers are 1, 2, 3, 4, 5. These are the values, remaining values. Using these 5 values, how many numbers can be formed? 5-digit number can be formed, which are divisible by 3. Of course, each number is divisible by 3 because the sum of these values is equal to 15. 1 plus 2 plus 3 plus 4 plus 5 is 15, right? Therefore, so 5-digit numbers can be formed. Neglecting 0, right, is equal to factorial 5. We can form a factorial 5 numbers. So which means 5 into 4 into 3 into 2 into 1. These many numbers. So 5-digit numbers can be formed using 1, 2, 3, 4, 5. Why we are taking factorial 5? Because there are 5 values. Here 5 is nothing but number of values. There are 5 values we are taking, right? So out of 5 values, so we have to form 5-digit numbers. Therefore, it is factorial 5, right? Second method is, right? So in another way is neglecting 3. Neglecting the value 3, the remaining values are 0, 1, 2, 4 and 5. Using these values, we have to form 5-digit number, right? Therefore, so number of 5 digits or number of 5-digit numbers, number of 5-digit numbers can be formed using these 5 values is equal to, since there are 5 values, according to the previous case, it is 5 factorial, right? But here is a twist. If the number starts with 0, right? If the number starts with 0, using all these 5 values, I'll write a number which starts with 0. 0, 1, 2, 4, 5 is also number, right? In which 5 values are there. But it is not a 5-digit number. Right? It is not a 5-digit number. Of course, it is divisible by 3 because some of the values 1 plus 2 plus 4 plus 5 is equal to 12, which is divisible by 3. Of course, it is divisible by 3, but it is not a 5-digit number. It is a 4-digit number. 4-digit number. Right? Therefore, there are many numbers which start with 0. Right? Such that, so here 0, 1, 2, 4, 5, for example, 0, 1, 2, 5, 4, 1254 is also a number, right? And 0, 1, 1, 4, 2, 5, 0, 1, 4, 5, 2, right? So like that, we can form many numbers, right? How many numbers can be formed, which is equal to 4 factorial numbers can be formed, right? Therefore, so number of 4-digit numbers can be formed using 0, 1, 2, 5, 4. Right? Using these numbers and start with 0. Here the condition is the number should be, so it should contain 0, but it should start with 0, right? And should start with 0 is equal to factorial 5. Of course, the number contains 0, but when we consider number of values, right, do not consider the first value, right? There are only 4 values, therefore it is 4 factorial, right? Therefore, number of 4-digit numbers can be formed is equal to 4 factorial. Therefore, in the second case, when we neglect 3, number of 5-digit numbers can be formed is equal to 5 factorial minus 4 factorial. Because this 5 factorial includes the numbers which start with 0 also, right? Therefore, it is 5 factorial minus 4 factorial. Come back to the question. Total number of ways this can be done. Total number of ways in which 5-digit number can be formed is equal to total ways in which 5-digit number can be formed is equal to, in first way, 5 factorial numbers can be formed, right? So 5 factorial number of 5-digit numbers can be formed, plus in the second case, 5 factorial minus 4 factorial, right? These many 5-digit numbers can be formed. So according to the options, so these are the whole number 3-digit numbers. So we'll simplify it. So 5 factorial, 5, what is the value of 5 factorial? Just simplify. So it is 5 into 3, 4 into 3 into 2 into 1 plus 5 into 4 into 3 into 2 into 1 minus 4 into 3 into 2 into 1. Simplify it. 20. So 20 into 3, 60. 60 into 2, 120 plus 120 minus 4 into 3, 12. 12 into 2, 24. Right? So it is 240 minus 24. So it is 216. Right? Right? So 216 is the right answer. Option A. That means 216 5-digit numbers can be formed using these 6 values. Right? So which are divisible by 3. Right? So option A is the right answer. Students, if you want to practice such questions on permutations, please visit our website www.examsnet.com. You can also download our app to practice some questions on permutations and combinations. The link is given in the description box. Question number 11. The product of r consecutive positive integers divided by factorial r is. Here the options are a proper fraction equal to r, a positive integer, and none of these are the options. So we'll consider the product of r consecutive positive integers. Here, let us consider positive integers as n plus 1. This is the first positive integer if you consider. Or you can consider 1 itself a positive integer, right? We don't know the value of the last r consecutive, that means the last rth positive integer, right? We don't know the value of r here. Therefore, we'll consider n plus 1 as first positive integer. The product of first into the second one into the third positive integer, right? Right? So on up to are consecutive positive integers, right? So this expression says the product of are consecutive positive integers, right, which are positive, divided by factorial r is equal to. Here we'll consider n plus r, the last term. Here the first term is n plus 1, right? We just multiply and divide this expression by factorial n, right? Multiply and divide the expression by factorial n. There will not be any change in the value, right? So the given expression becomes factorial n into n plus 1 into n plus 2, so on up to n plus r, divided by factorial r, right? So here factorial n is written as n into n minus 1, right? So into n minus 2 into n minus 3, so on, right? So I'll write n minus 2, so on up to 3 into 2 into 1, right? So which is nothing but factorial n into n plus 1 into n plus 2, so on up to n plus r. So to the value of n, we have yes, multiplied n plus 1, it's the next term. Again, this term is multiplied with the next term, which is n plus 2. So up to n plus r, it continues. Divided by, so we have to divide the expression by n factorial, right? So denominator becomes a factorial n into factorial r, right? Therefore, denominator is factorial n into factorial r. Now come to the numerator part. So numerator part is nothing but factorial n plus r, right? So n plus r, its previous term is, yes, n plus r minus 1, right? Therefore, so up to 1, so 3 into 2 into 1, therefore it is factorial n plus r divided by factorial n into factorial r, which is nothing but n plus r cr, right? So I'll write it down, n plus r cr. Since NCR is factorial n divided by r factorial into n minus r factorial. So n plus r factorial becomes n plus r factorial by n factorial into r factorial is n plus r cr. Right? Here n is a positive integer. It is given already. Product of r consecutive positive integers. Right? So it is since n plus 1 is a positive integer up to n plus r, these are all positive integers. So we have to consider n plus r is a positive integer. Therefore, n plus r cr is also a positive integer. Right? Since r is, so what's the value of r, whether it is greater than 1 or less than 1? So we don't know the value then, right? Since the whole value of n plus r is positive, n plus r cr is also a positive value, right? Therefore, so option C is the right answer, right? Option C is the right answer. You can consider the value of n and r by taking two examples, n as 7, r as 2, right? Any value you can consider, you will get a positive integer, right? Factorial n, ncr becomes, or n plus r cr becomes, so n plus r is 9c2, right? So factorial 9 divided by factorial 2 into 9 minus 2 factorial, which is 7 factorial. You will get a positive integer, right? So factorial 7 and in 9 factorial 7 will get cancelled. You have 9 into 8 by 2 factorial. So 2 into 4. So you will get 36, a positive integer, right? Like that. So for the given question, a positive integer, option C is the right answer. Question number 12. If 9p5 plus 5 into 9p4 is equal to 10pr, so what is the value of r, right? So we'll consider the given expression or given equation. 9p5 plus 5 times 9p4 is equal to 10pr, right? So 9p5 means, so factorial 9 divided by 9 minus 5 factorial plus 5 into. So 9p4 is factorial 9 by 9 minus 4 factorial. Since npr is equal to factorial n by n minus r factorial. We are using this formula, right? So right hand side becomes 10 factorial divided by 10 minus r factorial, right? Simplify it. Factorial 9 divided by factorial 4 plus 5 into factorial 9 divided by factorial 5 is equal to 10 factorial divided by 10 minus r factorial, right? So in this 5 factorial, right? So 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. So in that we can cancel 5 and 5 in the numerator, right? Therefore, the left hand side becomes 9 factorial by 4 factorial plus 9 factorial by, so here we have to cancel one 5 here. So in the 5 factorial, so denominator becomes 4 factorial is equal to, right, is equal to, so factorial 10 divided by 10 minus r factorial, right? So 2 times 9 factorial by 4 factorial, or here itself you can simplify, right? So 4 factorial is equal to factorial 10 by 10 minus r factorial. So 2 times, so in 9 factorial, so starting from 4, so 4 into 3 into 1, we can cancel 4 factorial and 4 factorial, and we have 9 into 8 into 7 into 6 into 5, right? And the remaining parts, 4 into 3 into 2 into 1, these parts will get cancelled with the denominator, right? Therefore, we have this value is equal to factorial 10 by 10 minus r factorial. Take this 10 minus r factorial to the left hand side is equal to, so factorial 10 is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Divided by, so 2 into 9 into 8 into 7 into 6 into 5, right? So here 9 and 9, 8 and 8, 7 and 7, 6 and 6, 5 and 5 will get cancelled. And 2 into 5 is 10. Therefore, we have 5 into 4 into 3 into 2 into 1, which is nothing but factorial 5, which is equal to 10 minus r factorial. Therefore, value of r is 5. So that 10 minus r becomes 5 factorial, right? So, value of r is 5. So, here option B is the right answer. Question number 13. There are 6 teachers. Out of them, 2 are primary teachers and 2 are secondary teachers. They are to stand in a row so that the primary teachers, middle school teachers and secondary teachers are always in a set. The number of ways in which they can do so is. Students, here the total number of teachers are 6, right? So 6 teachers. Among them, 2 are primary teachers, right? 2 are primary teachers and 2 are secondary teachers and 2 teachers are middle school teachers, right? 2 are middle teachers and the remaining 2 teachers are secondary teachers, right? So the number of ways in which they can do so, that means, if they are stand in a row, right? So in a row, in how many ways 2 primary teachers can be, or to the arrangement of 2 primary teachers can be possible in a row, so that they have to stand together, right? So they have to stand together in this particular order only, right? So 2 primary teachers, 2 middle school teachers and 2 secondary teachers in the same order, in how many ways their arrangement can be done, right? So number of ways 2 primary teachers can stand is nothing but 2 ways, in 2 ways, which is nothing but factorial 2 ways. Right? There are 2 teachers. In 2 ways they can stand. That means one teacher can stand at first and another teacher can stand after the first teacher. Or the second teacher can stand at first, right? first teacher can stand next to second teacher, like that. So only in two ways, factorial two ways means, so only in two ways, two primary teachers can stand, right, next to next, right? So similarly for middle school teachers, number of ways they can stand is factorial 2. So in two ways they can stand, right? Similarly for secondary teachers, so in factorial two ways they can stand, right? So if there are two teachers, so third teacher and fourth teacher, so they can just interchange their positions, right? Only then they can stand next to next, right, side by side. Therefore for the fifth and sixth teacher also, so just you can interchange their positions. Therefore number of ways they can stand is equal to two ways, right. So now come to the set of two teachers. So two primary teachers, so we'll take it as set 1, right? Set 1 contains two primary teachers, set 2 contains two middle teachers, and set 3 contains two secondary teachers, right? So the number of ways in which this set of teachers can stand, the whole set of teachers can stand, right? So you can just interchange the set 1, set 2, set 3. Like in how many ways? So you'll consider set 1, set 2, set 3. You can uh, take set 2 at first, set 1 and set 3. Or set 3, set 1, set 2. In how many ways this can be possible? In factorial 3 ways. That means in 6 ways, right? The arrangement of these 3 sets can be possible, right? So that set 3 teachers are 5 and 6, right? So they come at first. Then set 1 teachers 1 and 2, right? And again their arrangements in 2 ways, right? So here the arrangement of whole set, 3 sets, can be possible in 3 factorial ways. That is nothing but 6 ways, right? Therefore, so this is arrangement of three sets of teachers. Along with that, there are two ways into two ways into two ways of interchanging their positions, right, in their own set. Therefore, total number of ways in which 6 teachers can stand is equal to two ways in which two teachers can stand, two primary teachers, right? So two ways in which two middle school teachers can stand into two ways in which secondary teachers can stand into 6 ways in which 3 sets or arrangement of 3 sets can be possible, right? This gives 2 into 2, 6, sorry, 4, 4 into 2, 8, 8 into 6, 48. In 48 ways, the arrangement of 6 teachers can be possible. Or, so the ways in which 6 teachers can stand is equal to 48 ways. So given that, so set of primary teachers, so will be same. That means side by side they have to stand. And also for middle school teachers, also for secondary teachers, right? Therefore, for the given question, option B is the right answer. Question number 14. If 1002C 1001 is equal to 1002, then find the value of 1002C1. Here, student, 1002C 1001 is equal to 1002C1. Because we know that NCR is equal to factorial n is equal to R factorial n divided by R factorial into n minus R factorial, right? So use the same formula for 1002 C 1001 is equal to factorial 1002. Here n is factorial 1002. So it's factorial divided by R is 1001, right? So factorial 1001 into n minus r factorial, 1002 minus 1001 factorial, which is 1, right? Therefore, we have 1002 factorial by 1001 factorial, right? Whereas the second part, right, 1002 C1, 1002 C1 is equal to factorial 1002 divided by factorial r. R is 1 here, into 1002 minus 1 factorial, which is nothing but 1002 factorial by 1001 factorial, right? So both are same. 1002 factorial by 1001 factorial. Therefore, the value of 1002 C1 is also 1002. Since the value of 1002 C 1001 is equal to 1002, value of 1002 C1 is also 1002, right? Therefore, look at the options. Option D is the right answer, right? Otherwise, you can just simplify it, right? Finally, we have got 1002 factorial by 1001. So, which is nothing but 1002 into 1001 factorial divided by 1001 factorial. Therefore, we can cancel 1001 factorial and 1001 factorial. And the final answer is 1002, right? So, option D is the right answer. Question number 15. There are 10 stations on a railway line. The number of different journey tickets that are required by the authorities is. Students, let us consider 10 stations. So 1, 2, 3, 4, 5, 6 station, 7th, 8th, 9th and 10th station on a railway line. So number of different journey tickets that are required by the authorities. So for this, let us consider a person in station 1. Right. So he may purchase the ticket to go to second station, which is T2, or he can purchase the ticket to go to third station from first station, right? Like that. So he may take the ticket to go to 10th station, right? Therefore, so the total number of variety of tickets to go to different station in station 1 is equal to 9. Right? So there are 9 different varieties of tickets available in station 1. Right? Similarly, in station 2, a person in station 2 may go to first station. For that, he has to purchase ticket 1. If he wants to go to third station, he may purchase, right, ticket 3, like that. So up to 10th station. So there are 9 different varieties of tickets available in station 2. Similarly, in station 3, right, except that station, the remaining number of stations are 9, right? Therefore, so 9 different varieties of tickets are available in each station. So totally, there are 10 stations into 9 gives 90 varieties of tickets, right? Totally, it is 90 different tickets, right, available, right? So required by the authorities. Therefore, option B is the right answer. Question number 16. Everybody in a room shakes hands with everybody else. The total number of handshakes is 66. The total number of person in the room is. So here, students, for a handshake, 2 people are required, right? So 2 people are required for handshake who will shake hand with each other, right? So suppose there are n people, right? So suppose there are n people in the room, right? So we need to find the number of ways to make a pair out of n persons, right? So first person shakes hands with second person, right? Here we have made a pair of first and second person, right? Or third and fourth person pair. And also everybody in a room shakes hands with everybody else, first and fourth person pair, right? Therefore, so possible ways of making pairs here out of how many persons? Here we don't know, out of n people, right? And total handshakes is equal to 66, right? Therefore, here total handshakes is nothing but number of pairs can be made out of n people, right? Therefore, number of pairs can be made out of n people. N people is already given, which is equal to 66, right? So since it is making a pair, right? So number of handshakes, it is nothing but making a pair, right? So two people are required. Therefore, number of pairs can be made out of n people is nothing but nc2. We have to choose two people out of n people, right? Which is equal to 66, right? Therefore, nc2, it is factorial n divided by 2 factorial into n minus 2 factorial is equal to 66. Very easy. So it is factorial n is nothing but n into n minus 1 into n minus 2. So on up to 3 into 2 into 1. Whereas denominator becomes 2 into 1 is 2 factorial into n minus 2 into n minus 3. N minus 2 factorial is n minus 2 into n minus 3. So on up to 3 into 2 into 1 is equal to 66. So these two parts will get cancelled. So we have n into n minus 1 by 2 is equal to 66. Now find the value of n, right? N into n minus 1 is n square minus n is equal to 66 into 2 is 132. Take this 132 to the LHS part. N square minus n minus 132 is 0, a quadratic equation, right? Find the value of n by splitting the middle term, right? Quadratic equation. So n square middle term has the coefficient minus 1 and the last term is minus 132. So product of two numbers should be minus 132 and their sum should be minus 1, right? Which is coefficient of n. Therefore, middle term can be splitted as n square minus 12n plus 11n. So that product of minus 12 and plus 11 becomes minus 132, right? Minus 132 is the last term is equal to 0. Take first two terms where n is common. So we have n minus 12 as the second term. And in the last two terms, we have 11 as common and we have n minus 12 is equal to 0. Therefore, n minus 12 into n plus 11 is equal to 0. So we have two values for n. N is equal to 12 or n is equal to 11. So what is n? N is nothing but number of people, right? Number of people in that room. So number of people cannot be negative, right? So which is not possible. Therefore, value of n, so number of people in that room is equal to 12, right? Total number of people in that room is equal to 12, so that each person shakes hands with everybody else, right? So total number of handshakes becomes 66, right? So option B is the right answer. So total number of persons in that room is 12, right? You can verify the answer by taking, so NC2, 12C2 should be equal to 66. So factorial 12 divided by 2 factorial into 10 factorial. 12 minus 2 factorial is 10 factorial. Here 10 factorial and 10 factorial will get cancelled. In the numerator, we have 12 into 11 and the remaining part will get cancelled because remaining part is nothing but 10 factorial, right? And we have 2 in the denominator. So 2 into 6 is 12. So 6 into 11 is 66, right? Therefore, so option B is the right answer. Question number 17. In how many different ways can the letters of the word leading be arranged in such a way that the vowels always come together? So this part is very important, right? So the vowels, so three vowels in the given word E, A and I, right, should always come together. Therefore, we'll consider vowels in the given word E, A and I. Right? So wherever may be the position of these vowels, so always these vowels should come together, right? So either that means there are many ways, right, of arrangement of these vowels. So this arrangement is nothing but the number of different ways in which these vowels can be arranged is equal to 3 factorial, right? So which is nothing but you can arrange these vowels, right? So in this way, right? So with E in the beginning, then A and I, or E, I, A, or A, E, I, or A, I, E, or I, A, E, or I, E, A. these are the 6 different ways of arranging 3 vowels. Therefore, it is factorial 3. Factorial 3 is nothing but 3 into 2 into 1. Right? So, first part got over. Right? So, the vowels always come together. So, in how many ways? In 6 different ways. Right? And the second part is the remaining letters, consonants. Right? So, L, D, N, G. These are the remaining letters in the given word. Right? There are 4 letters, remaining letters. Ways of arranging these 4 letters. So what is the different ways, right, of arranging 4 letters? Is this factorial 4? No, which is wrong, right? Because including these 4 letters, there is a part, right, in which 3 vowels are arranged, right? Therefore, including these 4 letters, we have to consider the vowel part. Vowel part. It may be EAI or EIA or any other way, right? Any 6 ways. In these 6 ways, it may be any way, right? The vowels are arranged, right? They are together. Therefore, vowel part plus the remaining letters, L, D, N, G, right? Makes this arrangement, right? Therefore, it should be factorial 5. Factorial 5, right? Therefore, so first it is factorial 3, right, and factorial 5. So in these ways, what is factorial 3? 3 into 2, which is 6. Factorial 5 is 5, 4, 3, 2, 1. 5 into 4 into 3 into 2 into 1, which is 20 into 3, 60, 60 into 2, 120, right? Therefore, product of factorial 3 and factorial 5 gives total ways, right? In how many ways can these letters be arranged, right? In 3 factorial into 5 factorial, which is 6 into 120. In 720 ways, these letters can be arranged in such a way that vowels always come together. Right? Here the condition is vowels should always come together. Therefore, we have to go for that part first. Right? Go for the condition given. In how many ways vowels can be arranged? In 6 different ways, which is factorial 3, right? Into, so number of different ways in which the remaining letters, including the vowel part, be arranged is equal to factorial 5, because the whole vowel part, right, whole vowel part, so set of 3 letters, it may be AI or any way, right, set of 3 letters is considered as vowel part, and remaining 4 letters, right? So these are arranged in 5 factorial different ways, right? So which is equal to 120. Therefore, the total number of ways, so in which the letters can be arranged, is equal to product of 6 into 120, which is 720, right? Option D is the right answer. Question number 18. The number of triangles that are formed by choosing the vertices from a set of 12 points, 7 of which lie on the same straight line, are, right? So here are 12 points, set of 12 points. In that, 7 points lie on the same straight line. We'll consider a straight line on which, so 7 points lie. So 1, 2, 3, 4, 5, 6 and 7 points lie on the same straight line, and the remaining 5 points, 8th point, 9th point, we'll consider wherever we wish, right? 11th and 12th point, right? So how many triangles can be formed by choosing the vertices? To choose or to form a triangle, 3 vertices are required, right? For a triangle, 3 vertices are required. Therefore, we have to choose 3 vertices, right? So, for example, we can choose 2nd, 3rd and 8th vertex, right? These 3 vertices to form a triangle. Or you can choose 1, 2 and 8. Or you can choose 3, 4. Right? In how many ways or how many triangles can be formed, right? So, can we take 12C3 as number of triangles can be formed, right, out of 12 points? No. which is not possible, because out of 12 points, 7 points lie on the same plane, right? We cannot take these 7 continuous points, that means 1, 2, 3 points, right, to form a triangle, because if you join these points, you will get a straight line. You cannot take 3 points from these first 7 points, right? You cannot take 4th, 6th, and 7th point to form a triangle, right? Therefore, so 12C3 is the total triangles can be formed when points are not collinear, right? When points are non-collinear or not collinear, that means points do not lie on the same line, right? So wherever you wish, if you draw some points, you can form this. If you take 12 points, right, which are non-collinear, so you can form 12C3 number of triangles, right, using these points like this, right? Since 7 points lie on the same straight line, therefore you have to subtract these 7C3 number of triangles, right? 7C3 means, so number of triangles so can be formed if points are non-collinear, right? Therefore, you have to subtract 7C3 from 12C3 is equal to number of triangles formed, right? What is 12C3? 12C3 means factorial 12 by 3 factorial into 12 minus 3 factorial minus 7 factorial by 3 factorial into 7 minus 3 factorial, which is equal to, so 12 into 11 into 10 into 9, so on up to 2 into 1 by 3 into 2 into 1 into 12 minus 3 factorial is 9 factorial, right? So on up to 2 into 1. So you can cancel these two parts, right? Minus 7 factorial is 7 into 6 into 5, so on up to 2 into 1. And in the denominator, we have 3 into 2 into 1 into 7 minus 3 factorial is 4 into 3 into 2 into 1, right? Here 4 into 3 into 1, 4 into 3 into 2 into 1, this part will get cancelled. So we have 3 into 2, 6, 2 and 2 will get cancelled, right? So minus 35. And in the first part we have so 2 into 6 and 3 into 2, right? Therefore, we have 11 into 10, 110 into 2 is 220. Therefore, 220 minus 35, which is equal to 185, right? So, we can form 185 triangles out of 12 points, right? In which 7 are collinear, 7 points lie on the same line, and 5 are non-collinear, right? Therefore, 185 triangles can be formed, right? You can choose 2 points which lie on the same line, and the remaining third point which is not collinear, right? 1, 2, and 8, or 4, 5, and 9 you can form, right? But you should not take 3 points which are collinear, like 3, 4, 5, 2, 3, 4, or 2, 4, 5, like that. Therefore, 185 is the right answer. Question number 19. How many words can be formed by using all the letters of the word powerful such that the first and the last alphabet remains unchanged? Here in the word powerful, first and last letters, so P and L, so these two letters remain unchanged, right? Therefore, number of ways in which these two letters can be arranged is only one way. There is only one way in which these two letters can be arranged, because they remain unchanged means the letter P should be in its first place and L should be in its last place, right? You cannot interchange the position of P and L, right? That's what the the information is given in the question. So first and the last alphabet remains unchanged. There is only one way to arrange P and L letters, right? And the remaining letters are O, W, E, R, F, and U. There are 6 letters, right? Remaining letters are 6. Therefore, we can arrange these letters in factorial 6 ways, right? So we can arrange these letters in factorial 6 ways. So which is nothing but 6 into 5 into 4 into 3 into 2 into 1 ways, right? So which is equal to, so 30 into 4, 120 into 3, 360 into 2, 720, right? Therefore, so total number of ways in which letters can be arranged, given letters can be arranged is equal to, so number of ways in which the first and last letters are arranged is equal to only one way into number of times, or 720 times the remaining 6 letters can be arranged, right? Therefore 720 ways, or number of ways in which the remaining 6 letters can be arranged is 720 ways. Therefore it is 720 ways, right? Therefore option A is the right answer. Question number 20. There are 10 persons named A, B, C, D up to, it is not K, it is J, right? So A to J means there are totally 10 letters, right? So there are 10 persons named A, B, C, D up to J. We have the capacity to accommodate only 5. In how many ways can we arrange them in a line? If A is must and G and H must not be included in the team of 5. Right? Therefore, out of 10 persons, we need to neglect these 2 persons. That means you should not consider G and H. Right? These 2 persons must not be included in the team of 5. Therefore, here it is given that A is must. Person A is must. Right? A is must. He can be the first person, or in a line when you arrange 5 persons, 1, 2, 3, 4, 5. Right? You can place the person A wherever you wish. You can place him in the first place or second place, third, fourth or fifth place. Right? So here the remaining persons are A is must and the remaining persons are, so excluding J and H, the remaining persons are B, C, D, E, F, G and H are not included, I and J. Right? So these 7 persons should be included, right? Such that we have to select only 5 people, right? So here A is must, 1 person is must, and we have to select remaining 4 persons out of 7, right? Select 4 persons. In how many ways these 4 persons can be selected out of 7, right? So these 4 persons can be selected in 7C4 ways. Number of ways in which 4 persons can be selected out of 7 is equal to 7C4 ways. So which is nothing but 7C3. Both are same. 7C4 and 7C3 both are same, right? So if you apply the formula, it is factorial 7 divided by 4 factorial into 7 minus 3 factorial. 7 minus 4 factorial, which is nothing but 3 factorial, is equal to factorial 7 divided by 3 factorial into 7 minus 3 factorial, which is 4 factorial. Both are same, right? Therefore, 4 persons can be arranged, right, out of 7 persons in 7C4 ways or 7C3 ways, right? And 1 person A is must, right? So out of 5 persons, you can place A wherever you wish, right? Therefore, so including A, right? In how many ways these persons can be arranged? Right? 4 persons can be arranged in 7C4 ways or 7C3 ways, right? So in between them, A can be arranged in factorial 5 ways. right? Therefore, person A can be placed in a line, in factorial 5 ways, right? Why it is factorial 5 ways? Because we are placing 5 persons. These persons may be, so B, D, E, F, 4 persons, including A, right? Whoever they may be, excluding G and H, they are telling, right? So A, we can place A here also. B as the first person, D as the second person, E as fourth, and F as last one. Right? Like that, there are 3 ways of arranging the remaining 4 persons, right? Into factorial 5 gives total ways of arranging 5 persons. 5 persons. Right? Therefore, 7C4 into 5 factorial, or both are same, right? Or 7C3 into 5 factorial ways, right? In which 5 persons can be arranged, such that A is must in that group, right? So look at the options. Option D, right? 7C3 into 5 factorial or 7C4 into 5 factorial. Both are same, right? Option D is the right answer. Question 21. In how many ways can 2 spade cards be drawn simultaneously from a pack of 13 cards? So that means we have to select 2 cards out of 13 cards. In how many ways, right? So ways of drawing or drawing 2 spade cards. 2 spade cards out of 13 cards. So it's about combinations, right? So it is not talking about the order, right? So we should not choose or draw 2 spade cards in a particular order, right? So therefore, the question is based on combinations, right? So ways of drawing 2 spade cards out of 13 cards is equal to 13C2. In 13C2 ways, we can draw 2 spade cards, right? So which is equal to 13 factorial divided by 2 factorial into 13 minus 2. That is 11 factorial, right? So here 13 into 12 into 11, so on up to 2 into 1 divided by 2 into 1 into 11 into 10 into 9, so on up to 2 into 1. Here 11 factorial and 11 factorial will get cancelled, and 2 into 6 is 12. So 13 into 6 is 78, right? Therefore, so we can draw 2 spade cards out of 13 cards in 78 ways, right? In 78 ways, we can draw 2 spade cards. Therefore, option D is the right answer. That means consider 13 cards, right? 6, 7, 8, 9, 10, 11, 12, 13, right? Simultaneously, we can choose these 2, right? Or these 2, or first and second, or first and third, right? Like that, in 78 ways, 2 spade cards can be drawn, right? Option D. Question number 22. The expression 1 into 1 factorial plus 2 into 2 factorial plus so on up to n into n factorial is equal to. Here, students, the first term 1 into 1 factorial. So instead of 1, can I write 2 minus 1? Right? So we'll write 2 minus 1 into 1 factorial. Right? Plus, so in the second term, instead of 2, I'll write 3 minus 1 into 2 factorial. Right? And the next term becomes 4 minus 1 into 3 factorial. Right? And the next term becomes 5 minus 1 into 4 factorial. Right? So on up to, so instead of n, I'll write its next value, which is n plus 1, subtract 1. Right? N plus 1 minus 1 into n factorial. Right? So just expand these terms. So 2 minus 1 into 1 factorial can be written as 2 into 1 factorial minus 1 factorial, right? Plus, consider the second term, right? Expand the terms 3 into 2 factorial minus 2 factorial plus 4 into 3 factorial minus 3 factorial plus 5 into, consider the fourth term, 5 into 4 factorial minus 4 factorial plus so on up to, so here consider the last term, right? It becomes n plus 1 into n factorial, right? Minus n factorial, right? So now consider 2 into 1 factorial. So 2 into 1 factorial is nothing but 1 itself. So 2 into 1 is equal to 2 factorial. We can write 2 into 1 as 2 factorial, right? Similarly, 3 into 2 factorial. So 3 into 2 factorial is 2 into 1. Therefore, it is factorial 3, right? Similarly, 4 into 3 factorial, right? 4 into factorial 3 can be written as 4 into 3 into 2 into 1. Since factorial 3 is 3 into 2 into 1, into 4 gives factorial 4, right? So keeping this in your mind, so come back to the question. Here 2 into 1 factorial is 2 factorial minus factorial 1 plus the third term is 3 into 2 factorial, so which is nothing but factorial 3 minus factorial 2. So we'll keep this factorial 1 minus factorial 2, this part as it is. We are focusing the product of number and the next factorial, right? So next comes 4 into factorial 3, which is factorial 4 minus factorial 3. We'll consider 5 into factorial 4, which is factorial 5 minus factorial 4, right? Plus so on up to here n plus 1 into factorial n can be written as factorial n plus 1, right? Minus factorial n, right? Now here plus factorial 2 and minus factorial 2 will get cancelled, and 3 factorial minus factorial 3 will get cancelled, right? So factorial 4 minus 4 factorial will get cancelled. Similarly, factorial 5 and next comes minus factorial 5, right? So all the terms will get cancelled, right? Even factorial n, right, with negative sign, all the terms will get cancelled, and we have minus 1 factorial plus n plus 1 factorial at last, right? So here n plus 1 factorial minus 1 factorial is minus 1 itself. Therefore, the final answer is factorial n plus 1 minus 1, right? So here, looking at the options, so option C is the right answer, right? N plus 1 factorial minus 1 is the final answer. Question number 23. 7 men and 7 women are to sit around a table so that there is a man on either side of a woman. The number of seating arrangement is. So students, first we need to place 7 women in a circle, right? Since the table is in round shape, place 7 women in a circle, right? 7 women in a circle. So after that, in between 2 women, we need to place 1 man, right? Here the condition is so that there is a man on either side of a woman, right? So we need to place 7 men in such a way that there is a man on either side of a woman, right? So we'll consider 7 women. So 1, 2, 3, 4, 5, 6 and 7 women, right, in a circle. So number of ways, right, number of ways of placing 7 women. So we'll consider number of ways of placing 7 women in a circle is equal to, here position of 1 woman will be constant, right? Since it is a circle, so wherever you start, you have to end up with the same place, right? If you start from W3, third woman, right? If third woman is here, so second is seventh woman, next comes the sixth woman, next comes first woman, like that. If you place these 7 women in a circle, so you have to end with the same place, right? Same place means W3. Therefore, number of ways of placing 7 women in a circle is factorial 6. We need to consider the positions of remaining 6 women, right? Since there are 7 women, W1, W2, W3, W4, W5, W6, and W7, right? So keeping the position of one woman as constant, maybe W3, W5, right? So here we have taken W3 position is constant. You can change the position of remaining 6 women, right? So you can change position of W1. Instead of W1, you can place W6 here. That's right. You can place W4 in place of W2, or you can place W1 in place of W4, like that. In 6 factorial ways, we can change the position of 6 women, right? So here keeping W3 position constant. One position out of 7 women will be constant, right? Therefore, number of ways of placing 7 women in a circle is factorial 6. So in between them, right? So in between 2 women, we need to place a man, right? So another man, right? So 7 men should be placed between these two, right? On either side of a woman, 1 man should be placed. Therefore, number of ways of placing 7 men, placing 7 men is equal to, so in this case, it is factorial 7, right? Here you cannot keep position of one man. Say, for example, M1 constant. We cannot place M1 constant, right? Because on either side of M1, so there are 2 women, W7 and W3, right? Here the position of W7 keeps on changing, right? Therefore, so the position of M1 also changes, which is not constant here. Therefore, number of ways of placing 7 men will be factorial 7. Therefore, the question is, come back to the question, number of seating arrangement is, right? Or total number of ways of placing 7 men and 7 women is equal to product of factorial 6 and factorial 7. 6 factorial into 7 factorial. So option C is the right answer. Question number 24. 5-digit numbers are formed with 0, 1, 2, 3, and 4. The number of numbers in which at least one digit is repeated is. So here, students, we need to form 5-digit numbers using these 5 values, these 5 digits, 0, 1, 2, 3, and 4. Right? So first, let us find total number of 5-digit numbers formed by the given 5 digits. Right? So we have to find the number of non-repeated numbers, right? So 5-digit numbers in which the digits are non-repeated. So total number of 5 digits minus non-repeated numbers, or the numbers in which the digits are non-repeated, gives the total number of numbers in which at least one digit is repeated. Here, students, we are going to find the numbers in which the digits are repeated, right? At least one digit is repeated. So for that, we'll consider total number of 5-digit numbers. 5-digit numbers formed is equal to, using the given 5 digits. So we'll consider the 5-digit number like this, right? So this is 10,000s place. So this is thousands place. Next comes hundreds place, tens place, and units place, right? So in thousands place, using 0, 1, 2, 3, and 4, right? How many digits can be placed in 10,000 place out of the given five digits? So we can place only 4 digits because we cannot include 0 here. We cannot place 10,000, 0 in 10,000 place, right? Because if you place 0, then the remaining digits will be maybe 2, 3, 1, 4. It becomes a 4-digit number, right? Therefore, 0 cannot be placed in 10,000 places. Therefore, the number of digits can be placed in 10,000 is equal to 4, right? So you can place 1 or 2 or 3 or 4, right? So now here in thousands place, so to form a 5-digit number, even you can place 0 also in thousands place, because in 10,000 place we have already 1 or 2 or 3 or 4, right? In 1,000 place, if you place 0, so the number becomes 10,234. It is a 5-digit number, right? Therefore, in thousands place, you can place all 5 digits, right? And also in hundreds place, you can place all 5 digits, right? And in tens place also, you can place all 5 digits. In units place also, you can place all 5 digits, right? So here, this part is placing number of digits in the respective places, right? Therefore, total number of 5 digits, 5-digit numbers formed is equal to number of digits in 10,000 place into number of digits in thousands place into number of digits can be placed in hundreds place, so which is 5, into in tens place, into that of in units place. Therefore, total number of 5 digits numbers so formed is equal to 4 into 5 raised to 4, right? These many 5 digits numbers can be formed using the given 5 digits, right? Here the question is the number of numbers in which at least one digit is repeated. So we need to find only the numbers in which the given numbers are repeated. At least one digit is repeated. For that, let us consider the numbers or 5-digit numbers in which the digits are non-repeated, right? So we'll consider the total number of 5-digit numbers in which the digits are non-repeated. Digits are non-repeated is equal to, so again consider the place values, right? So 10,000 place, next thousands place, then hundreds place, tens place, and units place, right? So out of 5 numbers given, right? So how many digits can be placed in 10,000 place, right? How many digits can be placed in 10,000 place? So can we place 0, right? Can we place 0? No, 0 cannot be placed. Therefore, 4 numbers can be placed in 10,000 place, right? The reason is 0 cannot be placed. Cannot be placed. So if you place 0 in 10,000 place, it becomes a 4-digit number, right? Therefore, 0 cannot be placed. So 4 digits can be placed in 10,000. Whereas in thousands place, if you place already one digit in 10,000 place, how many digits are left? 4 digits are left. Remaining all 4 digits can be placed in thousands place, right? Therefore, sort of the given 5 digits, so 1, 2, 3, 4, and 0. So one digit cannot be placed in 10,000. Therefore, 4 digits can be placed in 10,000 place, right? So if one digit is already placed, say for example, 1 is already placed in 10,000, right? Or 2 is already placed in 10,000. The remaining digits are 0, 1, 3, and 4. Therefore, 4 digits can be placed in thousands place, right? And if one digit is already placed, for example, 3 is placed, right? 3 is placed here. So how many digits left here? So 0, 1 and 4, right? Therefore, 3 digits can be placed in hundreds place, right? So here, for example, we have placed 0 here in hundreds place, right? 100 place. So how many digits left? 1 and 4. So 2 digits can be placed in tens place, right? So I'll take 1 in tens place, right? So the remaining digits are, it is only 1. Therefore, one digit can be placed in unit place, which is 4 here. Therefore, the number becomes 23,014. So in which no number is repeated, right? No number is repeated. So a non-repeated digits, right? Number formed by the digits which are non-repeated. Therefore, number of ways in which a 5-digit number can be formed, in which the digits are non-repeated, is equal to, so 4 into, here 4 digits can be placed in 10,000 place, into 4, into 3, into 2, into 1, right? So 4 into 4, into 3, into 2, into 1. So you will get 96, right? Therefore, 96 numbers can be formed in which the digits are non-repeated. Therefore, total number of 5-digit numbers, in which at least one digit is repeated, is equal to, so here total number of 5-digit numbers can be formed is equal to 4 into 5 raised to 4, right? So this includes repeated and non-repeated digits, right? Therefore, so total number of 5-digit numbers formed minus 5-digit numbers in which digits are non-repeated, right? So total 5-digit numbers, minus, so 5-digit numbers in which digits are non-repeated, right? So we can form 4 into 5 raised to 4 number of 5-digit numbers. So in which the digits are both repeated and non-repeated, right? Minus 5-digit numbers. How many 5-digit numbers can be formed in which digits are non-repeated? 96 5-digit numbers can be formed, right? So simplify it. So 4 into 5 raised to 4 is nothing but 2500 minus 96 is equal to 2404, right? Therefore, we can form 2404 number of 5-digit numbers in which at least one digit is repeated. So option D is the right answer. Question 25. Out of 18 points in a plane, no 3 are in the same straight line except 5 points which are collinear. The number of straight lines that can be formed joining them is. Here students, out of 18 points, 5 points are collinear. Collinear means 5 points are in a same straight line, right? We'll consider 5 points in a same line, straight line, right? Which are collinear, right? And the remaining 13 points, right? In the remaining 13 points, it is given that no 3 points, no 3 are in the same straight line. That means no 3 points are in the same straight line. So you cannot consider 3 points in the same line like this, right? Which I am showing here. So no 3 points are there in the same straight line. So 3, 3, 3, 9, 10, 11, 12, 13, right? The remaining 13 points which are in a plane which are non-collinear. These are non-collinear points, right? Here the question is, number of straight lines that can be formed joining them is. right? So number of straight lines can be drawn joining 2 points here. It is nothing but number of straight lines formed by joining 2 points. 2 points, right? Here there are 18 points. Totally there are 18 points, right? So here you should not consider the straight line by joining first 3 points which are collinear. Here I am showing, right? So 1, 2, 3, first 3 points, you should not consider this line because this line contains 3 points here, right? Therefore, so just avoid these type of lines. How to avoid that? For that, we'll consider total number of straight lines that can be formed out of 18 points, right? So how to find total number of straight lines? For that, we have to consider number of points required to draw a straight line, right? So at least 2 points are required to draw a straight line, right? According to the condition, you should not consider more than 2 points here, right? Therefore, so number of points required to draw a straight line is equal to 2, right? So out of 18 points, how many straight lines can be drawn? Therefore, number of straight lines drawn out of 18 points. How many number of straight lines can be drawn out of 18 points? So this question is related to the combination, right? How many combinations can be made or how many straight lines can be drawn out of 18 points, which is nothing but 18C2, right? So 18C2 is nothing but factorial 18 divided by 2 factorial into 18 minus 2 factorial. We are using the formula n factorial by r factorial into n minus r factorial is NCR, right? Here, this gives total number of straight lines can be drawn out of 18 points, right? So here the condition is, so there can be maximum of 2 points, right, on a straight line. Here, another condition is no 3 lines in the same straight line. Therefore, so the 5 points which are collinear, right? So in which number of lines can be drawn out of 5 points, collinear points, right? So we have to consider total number of lines can be drawn out of 5 points. So these lines should be subtracted, right? Therefore, so total number of lines or straight lines out of 5 collinear points. 5 collinear points. Again, it is, so out of 5 points we are considering, so it is 5C2. 5C2 number of straight lines can be drawn, right? So which is 5 factorial by 5 minus 2 factorial into 2 factorial, right? But by joining first and the last point, so considering first and the last point, by joining, this whole part is considered as a single line, right? Therefore, so the total number of straight lines drawn is equal to, so the total number of straight lines out of 18 points, which is 18C2, minus number of straight lines out of 5 collinear points is equal to 5C2. We have to subtract because out of 5 linear points, so we can draw a straight line by using 3 or more than 3 points also. Even we can draw by joining 2 points also, right? Therefore, just to avoid this part, we are subtracting 5C2 from 18C2 and plus 1 straight line can be drawn, right? Because So by joining all these collinear points, first and the last point, you can get a straight line. Therefore, we have to add 1. So simplify it. 18C2 is nothing but 18 factorial divided by 2 factorial into 18 minus 2 factorial minus 5 factorial by 2 factorial into 5 minus 2 factorial plus 1. Therefore, here, so directly I'll go to simplification. Here it is 16 factorial in the denominator into 2 factorial minus 5 factorial by 2 factorial into 3 factorial plus 1. So this 16 factorial and in the numerator, the 16 into 15, that part will get cancelled. Therefore, we have 18 into 17 in the numerator and in the denominator, we have 2 factorial, which is 2 into 1. Whereas in the next part, we have 5 factorial. So 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. So that 3 into 2 into 1 part will get cancelled with the 3 factorial part, right? Therefore, we have 5 into 4 by 2 factorial plus 1. So we have 17 into 9, which is 153 minus 5 into 2, which is 10 plus 1. So 143 plus 1 is equal to 144. Therefore, totally we can form 144 lines, straight lines, right, out of 18 points, such that no 3 points lie in the same straight line, right? No 3 points lie in the same straight line, right? Therefore, option B is the right answer. Question number 26. How many 3-digit positive integers can be formed by using first 7 natural numbers if no digit occurs more than once in each number? Here the condition is, this is the condition or order, right? No digit occurs more than once, right? So here using first 7 natural numbers, which are 1, 2, 3, 4, 5, 6 and 7. Using these 7 numbers, how many 3-digit numbers can be formed, right? So for that, if the condition is not given, right, then number of 3-digit numbers can be formed will be equal to 7C3. Out of 7 numbers, right, 3-digit numbers can be formed is equal to 7C3. Here the condition is given. We have to form a 3-digit number in a particular order, right? In a particular order, you have to form 3-digit number. Therefore, we have to go for permutation, right? Therefore, 7P3 number of numbers can be formed, right? Therefore, 7P3 is nothing but factorial 7 divided by 7 minus 3 factorial. Since NPR is factorial n by n minus r factorial. So 7P3 is factorial 7 by 7 minus 3 factorial. So which is factorial 7. So is 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 4 factorial, which is 4 into 3 into 2 into 1. So this 4 factorial part will get cancelled. So we have 7 into 6 into 5. So 6 into 5, 30. 30 into 7 is 210. Right? So 210 such numbers can be formed. Right? So the condition is no digit occurs more than once in each number. Right? So option A is the right answer. If the condition is not given, then you have to go for combinations. That means all possible combinations can be formed. So which is equal to 7C3, right? All possible combinations means you can form a number 122, which is also 3-digit number, in which the number 2 occurs 2 times, right? Here the condition is not given in combinations, right? Whereas in permutations, so in a particular order, you have to form a number, right? Therefore, how many such numbers can be formed? 210 such numbers can be formed. Question 27. In how many ways can 2 balls be drawn with repetition among 7 balls of different colors? So here we'll consider 7 balls of different colors. right? Right? In how many ways can two ball be drawn, right? With repetition, right? That means, so you can draw first and second ball, or you can draw first and third ball at a time, or you can draw first and fourth ball, or first and fifth ball, or first and sixth ball, or first and seventh ball. That means for each ball, right? So its combination with other balls, maybe first and second, first and third, right? There are 6 possibilities for each ball, right? For each ball, there are 6 possibilities of drawing with other ball, right? Therefore, for totally 7 balls, right? Therefore, for 7 balls, right? For each ball, 6 possibilities. Therefore, for 7 balls, there are 42, right? 42 possibilities of drawing 2 balls. With repetition means you can draw first and second, or in another case, you can draw first and sixth also. That means, so again, you can draw first ball, right? So ways of drawing 2 balls out of 7 balls, right? So is equal to 42. There are 42 possibilities, which is nothing but 7p2, right? This question is based on permutations, right? Permutations means in how many ways two balls can be drawn, right? Or 2 balls, so we'll consider randomly 7 balls. In how many ways 2 balls can be arranged? If the question is asked in simple way, in how many ways 2 balls can be arranged, right, of different colors? So you can draw, so if you consider whip cure as seven balls, right? So you can arrange violet and blue, you can arrange violet and green, violet and yellow, violet and orange, right? So in this way, so in how many ways these balls can be arranged, right? Therefore, so the question is based on permutation, which is 7p2, which is factorial 7 by 7 minus 2 factorial, which is nothing but factorial n by n minus r factorial, right? So factorial 7 divided by 5 factorial. So in 7 factorial, we have 7 into 6 into 5 into so on up to 1. And in 5 factorial, we have 5 into 4 into so on up to 1. This 5 factorial part will get cancelled. We have 42, right? So there are 42 possibilities of drawing 2 balls, right? Randomly with repetition out of 7 balls, right? Therefore, option B is the right answer. Question 28. A box contains 2 white balls, 3 black balls, and 4 red balls. In how many ways can 3 balls be drawn from the box if at least 1 black ball is to be included in the draw? Right? So let us consider a box in which number of balls are 2 white balls, then 3 black balls, and 4 red balls. Right? So we have to draw 3 balls out of the box, 3 balls out of the box, so such that at least 1 black ball is to be included, right? So in that, at least 1 black ball, right? 1 black ball is to be included, right? So let us consider number of black balls here. So there are 3 black balls given, right? So in that 3 black balls, you can draw only 1 black ball while drawing, or you can draw 2 black balls while drawing, right? Or you can draw all the 3 black balls. Here the condition is we have to draw 3 balls out of the box, right? So what are the remaining balls? 2 white balls, 2 white balls and 4 red balls. There are totally 6 balls remaining, right? Remaining balls are 6 balls, right? So if 1 black ball is drawn, right? So in how many balls need to be drawn here? So 2 balls from the remaining balls we have to draw, right? If 1 black ball is drawn, so we have to draw 2 more balls in the remaining balls, right? So if 2 black balls are drawn, right? The remaining balls will be 1. So that we have to draw totally 3 balls, right? If all the balls drawn are black balls, so there are no balls in the remaining part, right? Because already we have drawn 3 black balls, right? So number of ways of drawing 3 balls. So we'll consider number of ways of drawing 3 balls. All the 3 balls. Here, number of ways of drawing 1 black ball is nothing but 3C1. That means out of 3 black balls, so if you consider only 1 ball, which is black, so there are 3C1 ways of drawing black balls, right? Which is nothing but 3 ways of drawing. So the meaning of this statement is there are 3 black balls like this. You can draw first one or second one or third one. There are only 3 ways of drawing 1 black ball, right? Which is nothing but 3C1 into number of ways of drawing 2 the remaining balls. It may be white balls or red balls. 1 white ball or 1 red ball, or both white balls, right? In the remaining 6 balls, 1, 2, 3, 4, 5, 6, 2 are white and 4 are red. Like, right? So number of ways of drawing 2 balls will be, so 1 white, 1 red, or both white balls or both red balls, right? Right? So there are many ways of drawing 2 balls from the remaining balls, right? Or first white ball and last red ball, right? So which is equal to, so 6C2, total number of remaining balls. C2 means we have to draw 2 balls, right? Which is equal to 3C1 is nothing but 3 itself. Factorial 3 divided by 1 factorial into 2 factorial. So 2 factorial part will get cancelled. So we have 3 into 6C2 is nothing but factorial 6 by 2 factorial into 4 factorial, which is nothing but 15. There are 45 ways of drawing 3 balls, right? If one ball is black and the remaining balls are white or red, there are many combinations, right? So 45 ways. In the second case, case 2, right? If 2 balls are black, so we'll consider, so out of 3, if 2 balls drawn are black, how many ways of drawing black balls? Here, either you can draw first and second black ball, or second and third black ball, or first and third black ball, right? So which is nothing but, so 3C2. 3C2 is nothing but factorial 3 divided by factorial 2 into 1 factorial, which is 3 itself. So into 6C1, right? Out of 6 balls, so we have to draw only 1 ball, right? So either you can draw first or second or third or fourth or fifth or sixth. So which is nothing but 6 ways. So which is nothing but 6C1. So 3 into 6, which is 18, right? Number of ways of drawing 3 balls in case 3. Case 3. So we have 3 ways of drawing all the 3 black balls, right? Which is nothing. There is only one way of drawing all the 3 black balls. So you have to draw all the 3 black balls. This is the only way, right? Which is 3C3. Number of black balls 3. C 3. 3 is nothing but number of balls drawn into 6C0, which is nothing but 1. Therefore, here 3C3 is nothing but 1, right? So NCN is always 1. So 1 into 1 is 1. There is only one way of drawing all the 3 balls, right? So such that the number of balls drawn should be equal to 3. So total number of ways of drawing 3 balls will be 45 plus 18, which is 55, 63 plus 1 is 64, right? There are 64 ways of drawing 3 balls. Out of how many balls? 3 plus 2 plus 4, which is out of 9 balls, in which 3 are black balls. right? Here the condition is at least one black ball is to be included, right? So option A is the right answer. There are 64 ways. Question 29. There are m points on a straight line AB and n points on another line AC, none of them being the point A. Triangles are formed from these points as vertices when A is excluded and A is included. So in these two situations, so the triangles can be formed, right? Using m and n number of points. Then the ratio of the number of triangles in two cases is. So here students, we need to find number of triangles formed in first case. That is when vertex A is excluded, right? Without vertex A. And with vertex A, how many number of triangles can be formed? That we need to find first. Then finally, we are finding the ratio of these two numbers. For that, let us consider a line AB. So AB be a line. And there are m points on a straight line AB. And given that none of them being the point A, that means we should not consider point A here. So we'll start with point 1, point 2, point 3, up to, so on up to point M. That means there are m points on line AB, excluding A, right? And n points on line AC. So we'll consider line AC, right? So we'll consider line AC. And there are n points excluding A, right? So line 1, 2, 3, 4, so on up to n points, right? So let us find number of triangles formed when A is excluded, when A is included, right? So when A is excluded, this is the first case. And in the second case, when A is included, right? So consider A is excluded. We are not considering point A, right? So we have 1, 2, 3, so on up to m points on AB and 1, 2, 3, so on up to n points on AC, right? So here we can form a triangle by considering 1 and 2 points on AB, right? These 2 points and another point on AC, right? So that a triangle can be formed. So you cannot consider all 3 points on the same line, right? Because the points are collinear. They lie in the same plane. You will get a straight line if you consider all 3 points from the same line, right? Therefore, so there are two cases. Either you have to consider 2 from AB and 1 from AC, or 1 point from AB and 2 points from AC. These are the two cases, right? Therefore, total triangles formed in this case when A is excluded is equal to, so out of m points, we have to select 2 points, right? Therefore, it is MC2. And out of n point, you have to select only 1 point, right? Therefore, it is n into NC1. Right? Therefore, number of triangles can be formed is MC2 into NC1. And we have another case, right? So, where we have to select only 1 point out of m points, right? Therefore, it is MC1 into, we have to select 2 points from line AC, right? Therefore, it is NC2, right? This gives total number of triangles formed when A is excluded, right? Without point A. Simplify it. MC2 is m into m minus 1 divided by 2. Since we are using the formula of NCR here, right? Factorial n divided by r factorial into n minus r factorial, right? So here MC2 on simplification, you will get m into m minus 1 divided by 2. And NC1 is nothing but n itself, right? So plus MC1 is m itself, NC2 is n into n minus 1 by 2. On simplification, we'll have m into n by 2 into m plus n minus 2. right? Here m into n by 2 is common. So we have mn by 2 into m plus n minus 2, right? So these are the number of triangles can be formed when A is excluded. So consider when A is included, right? When A is included, so to form a triangle, we need 3 points, right? To form a triangle, we need 3 points. Here, one of the points is A, right? We have considered one of the points is A. We'll consider one point from line AB. This is the first point. You cannot consider the third point on the same line AB because you will get a straight line if you consider the second point. So the point 2 from the same line AB. So if you join all these points, you will get a straight line. Therefore, you have to consider the third point from another line AC. Right? You may consider second point, third point, or fourth point. Right? Any point you can consider. By joining all 3 lines, you will get a triangle. Right? So in this way, how many triangles can be formed? Right? When A is included. So A is 1 point. Right? 1 point is A plus 1 point from AB plus 1 point from AC. Therefore, triangles or number of triangles can be formed. Can be formed with A, right? When A is included, right? With vertex A. I'll mention with vertex A is equal to, so 1 point, right? We have to select 1 point as A into out of m points. So on line AB, out of m point, you have to select 1 point. Therefore, it is MC1 into NC1, right? With vertex A, you can form MC1 into NC1 number of triangles, which is MC1 is M, NC1 is N. Therefore, Mn number of triangles can be formed with vertex A, right? Without vertex A also, you can form number of triangles, right? Which is nothing but without vertex A means when A is excluded, right? Without vertex A, you can form mn by 2 into m plus n minus 2, right? Therefore, total triangles formed is equal to triangles with vertex A. In the second case, you have to consider with vertex A plus without vertex A. Without vertex A, right? Totally, we can form m into n plus mn by 2 into m plus n minus 2 number of triangles in the second case, right? So simplify it. Here mn is taken outside. So 1 plus m by 2 plus n by 2 minus 1, right? When you multiply the second term m plus n minus 2 by, when you multiply with 1 by 2, you will get this term. So mn into, here 1 and 1 will get, minus 1 will get cancelled. So we have m plus n by 2, which is nothing but mn by 2 into m plus n, right? Consider this as equation 2 and the first one as equation 1, right? So come back to the question. The ratio of number of triangles in the 2 cases is, so in the first case, so required ratio is, we'll consider required ratio is equal to, so in the first case, when A is excluded, mn by 2 into m plus n minus 2 number of triangles can be formed. In the second case, it is mn by 2 into m plus n number of triangles can be formed, right? So it is clear, right? M plus n minus 2, right? Minus 2 number of, so less number of triangles can be formed in the first case because A is excluded here, right? So it is subtracted, right? 2 is subtracted here. So in the second case, we can form more number of triangles because we have included A also, right? Therefore, the required ratio is m plus n minus 2 by m plus n, right? Therefore, So the ratio is, look at the options. Option A, m plus n minus 2 by m plus n. Question number 30. 10 persons are to speak at a meeting. The number of ways in which it can be arranged if A wants to speak before B and B wants to speak before C. Here, students, the condition is, or the order is, A wants to speak before B and B wants to speak before C. Right? The order is, so first A, then B, then C. Right? And there are 10 persons to speak. Right? So if we consider A to J as 10 persons, right? A, B, C, D, E, F, G, H, I, and J. These are 10 persons, right? We have to arrange their positions in possible ways, right? There are many possible ways to arrange these persons, and only condition is A should come before B and B should come before C, right? So there are many such ways like D, E, A, B, C, then F, G, I, H, J, right? So D, F, then G, I, A, B, C. However, you make the positions like this. So the condition is the order of A, B, C should be like this, right? A wants to speak before B and B wants to speak before C, right? In how many ways this arrangement can be done? For that, so we'll consider A, B, C arrangement, right? A wants to speak before B and B wants to speak before C, right? So this arrangement can be done in 10C 3 ways, right? Out of 10 people, there are 10 persons, right? 10 persons. We have to select 3 persons, right? And we have to arrange their order, right? A, B, C in 10C 3 ways, right? And this arrangement, A comes before B and B comes before C, is possible only in one way, right? Only in one way. Therefore, it is 10C3 into one way, right? Right? Because A has to speak before B, right? You cannot make the arrangement as BAC or CAB like this, right? Therefore, according to the condition, so it is 10C3 ways into one way, right? And come back to the question here. So the arrangement of 3 persons is done, right? The remaining persons are 7 persons, right? 7 persons. So in how many ways the arrangement of 7 persons can be done? So in factorial 7 times, right? So number of ways the arrangement can be done is equal to factorial 7, right? That means if you consider D, E, F, G, H, I, and J, these 7 persons, you cannot, that means you can arrange these persons in many ways like D, F, E, G, H, or you can consider E as the first person, right? Then F, G, D, like this. In factorial 7 times or 7 ways, the arrangement of 7 persons can be done, right? Therefore, come back to the question. So here the number of ways in which it can be arranged, these persons can be arranged is equal to, so we'll consider total number of ways. Total number of ways. 10 persons can be arranged, or in which arrangement or number of ways these 10 persons can speak is equal to 10C3 into 1, right? So number of ways in which these 3 persons can be selected, right? Into factorial 7, right? Number of ways in which the remaining 7 persons can be arranged is equal to 10C3 is nothing but factorial 10 by 3 factorial into 10 minus 3 factorial. We are using the formula NCR is n factorial by n minus r factorial into r factorial, right? and the second term is factorial 7, right? Therefore, it is 10 factorial into 7 factorial by 3 factorial into 7 factorial. So we can cancel 7 factorial here. So 10 factorial by 3 factorial is 3 into 2, which is 6, right? Therefore, in 10 factorial by 6 number of ways, right? So in 10 factorial by 6 number of ways, these 10 persons can be arranged. And the condition is the position of A should be before B and B should be before C. Right? A wants to speak before B and B wants to speak before C. Hence, option C is the right answer. Question 31. So there is a 7-digit telephone number with all different digits. If the digit at the extreme right and extreme left are 5 and 6 respectively, find how many such telephone numbers are possible. So here 2 digits are given, right? So there are 10 different digits can be taken from 0 to 9, right? We can take 0 to 9 digits and it is given that so the telephone number with all different digits, no digit is repeated here, right? So we have to take the numbers from 0 to 9, right? 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In that, 5 and 6 numbers are already taken, right? Where 5 is extreme right number, right? So 5 is extreme right. Extreme right. So sorry. Here 5 is taken extreme right and R is taken so in the extreme left, right? In between 5 and 6, how many numbers are there? So 5 numbers because the telephone number is a 7-digit number, right? There are 5 numbers, A, B, C, D, and E numbers, right? There are 5 numbers in between 5 and 6, right? So in how many ways these numbers can be arranged? How many telephone numbers can be taken, right? In such a way, right? So these numbers can be taken out of 10 minus 2 numbers because 2 numbers are already taken which are fixed. These 2, 5 and 6 are fixed numbers. So out of remaining 8 digits 0, 1, 2, 3, 4 and 7, 8 and 9, right? Out of 8 digits, in how many ways these numbers can be taken? So we have to pick only 5 numbers. In how many ways these 5 numbers can be taken? Therefore, ways of arranging 5 numbers out of 8 digits or 8 numbers, both are same, is nothing but 8p5. 8p5. There is no particular order here, right? So in any way you can arrange these 5 numbers, right? So out of 8 numbers, so which is nothing but 8 into, so factorial 8 divided by factorial 3, right? 8p5 is nothing but factorial 8 divided by 8 minus 5 factorial, which is nothing but factorial 8 divided by 3 factorial. We are using the formula NPR is equal to factorial n divided by n minus r factorial here, right? Therefore, 8 factorial is nothing but 8 into 7 into 6 into 5 into 4 into 3 factorial divided by 3 factorial, right? So we can cancel 3 factorial and 3 factorial. So 8 into 7 into 6 into 5 into 4. So we'll get 6,720. So in 6,720 ways, we can arrange 5 numbers out of 8 numbers, right? Right? Therefore, look at the options. Option C is the right answer. I'll repeat once again, students. So here is a 7-digit telephone number. In that, 2 digits are already given and with their positions are fixed, right? The position of 2 digits are fixed. Therefore, in between 5 and 6, so there are 5 numbers. These 5 numbers should be taken from 8 numbers. from 0 to 9, right? 0 to 9. So we have totally 10 numbers. In that, 2 numbers are already taken. So we have left with 8 numbers. So in that 8 numbers, we have to arrange 5 numbers. In how many ways we can arrange? In 6,720 ways, these numbers can be arranged, right? Keeping first and last digits fixed, right? Therefore, option C is the right answer. Question 32. In how many ways 3 dresses can be stored in 5 boxes? So let us consider 5 boxes, students, right? And we'll consider 3 dresses. 1, 2, 3 dresses. In how many ways these 3 dresses can be stored in 5 boxes? Right? There are many ways, right? So you can store all the 3 dresses in one box, right? So this choice is also possible for second one, right? So you can store in second box also all the 3 dresses, or you can store in third, fourth, fifth box, right? Or another way is you can store one dress in one box, another in another box, another in third one in next box. Or you can store one dress in one box, another 2 dresses in next box, right? So like that, here each dress, there are 3 dresses. Each dress has 5 choices, right? 5 ways, right? So each dress can be stored in first box, second box, third box, fourth box, or 5 box, right? So each dress has 5 ways or 5 possibilities. It has 5 choices, right? We can store in any boxes, right? There are 3 dresses here. Therefore, number of ways in which these dresses can be stored, right? 3 dresses can be stored is equal to, so number of boxes n raised to number of dresses. If you consider number of dresses as r, right? So number of boxes are 5 raised to 3, right? Which is equal to 5 into 5, 25 into 5 is 125 ways, right? In 125 ways, we can store each dress, right? So that means you can considering one dress, right? So just consider one dress in one box. This same dress can be stored in 5 different ways, in 5 different boxes also, right? Either in 1 or in 2, also in 3, also in 4, also in 5. Consider 2 dresses. These 2 dresses can be stored in 5 different ways, right? So into 5. And also consider 3 dresses in 5 different ways, right? If you consider these ways, just adding these ways, 5 plus 5 plus 5, there are plenty, right? So consider 1 and 2 dresses. 1 dress from one box, 2 dress from another box. There are also 5 possibilities, right? So 1 dress from first box, 1 dress from another box, right? So in this way, we have totally 125 possibilities of storing 3 dresses in 5 boxes. So 125 is nothing but 5 raised to 3. Hence option B is the right answer. Question number 33. A 5-digit number divisible by 3 is to be formed using the numericals 0, 1, 2, 3, 4, and 5 without repetition. The total number of ways this can be done is. So here are 6 digits given, right? 0, 1, 2, 3, 4, and 5. So using these 6 digits, we have to form 5-digit numbers, right? And this 5-digit number should be divisible by 3. Right? Here, let us consider the divisibility rule of 3. It says a number is divisible by 3 only if it's a sum of the digits, right, is equal to 3 or multiples of 3. So in the given digits, so we'll consider sum of the digits, right? So 0 plus 1 plus 2 plus 3 plus 4 plus 5 is equal to 15, which is divisible by 3. 15 is a multiple of 3, or it is divisible by 3. right? Therefore, we can easily form 5-digit numbers, right, using these six numbers. So here the condition is you have to avoid 0 or 3, right? If you avoid 0, 15 minus 0 becomes 15, right? Sum of the remaining digits 1, 2, 3, 4, and 5. These digits becomes 15, right? Right? So then only you can form 5-digit number. You cannot consider all the six digits at a time to form 5-digit number, because we need only 5 digits, right? So if you avoid 3, so sum of the digits becomes 15 minus 3, which is 12, which is divisible by 3. That means you have to consider 0, 1, 2, 4, and 5, these 5 digits, right? Therefore, we have two chances of taking these digits. One is with, or we'll consider without 0, right? And another case is without 3. Without 3. Out of 6 digits, in first case, we are taking 1, 2, 3, 4, and 5. So that their sum is equal to 15, and which is divisible by 3. In any way, if you arrange these 5 numbers, right? Why to arrange these 5 numbers? To form a 5-digit number, right? So in any way, if you arrange these 5 numbers, their sum will be equal to 15, which is divisible by 3. Right? So without 0, in how many ways these 5 digits can be arranged? Right? So number of ways the digits are arranged to form a 5-digit number. It is understood that this number is divisible by 3, since we have already taken their sum, right? So number of ways the digits are arranged to form 5-digit number is factorial 5. So here are 5 digits, it is 5 factorial, right? So it is 5 factorial. Let us consider without 3. Without 3, how many digits we are considering? What are the digits? 1, 0, 2, 4, and 5. We are considering these numbers, right? Using these numbers, how many digits can be formed? So according to the rule, here are 5 digits, therefore it is 5 factorial. But if you take 0 as the first number, right? If you consider 0, 1, 4, 5, 2, it becomes 1452. It becomes a 4-digit number, right? In how many ways these 4 digits can be arranged? In factorial 4 ways, right? Therefore, this factorial 4 ways, right? So these ways to be subtracted from factorial 5 ways. Then only you can form a 5-digit number, right? So therefore, we'll consider this. First, number of ways to form a 5-digit number. Is equal to, so here are 5 numbers, 0, 1, 2, 4, and 5, which is 5 factorial, right? So if the number starts with 0, it becomes a 4-digit number. For example, so 0, 4, 1, 2, 5, 4125, right? Therefore, though it is divisible by 3, sum of the digits is divisible by 3, so it is not a 5-digit number. Therefore, number of ways of forming a 4-digit number. Forming a 4-digit number, it is nothing but a number starts with 0. Is equal to factorial 4. Right? Apart from 0, there are 4 digits. Therefore, it is factorial 4. Therefore, total number of ways of forming 5-digit number. total number of ways of forming 5-digit number. 5-digit number is equal to, it is understood that using numbers 0, 1, 2, 4 and 5, right? Right? So is equal to factorial 5. So in general case, we are taking factorial 5 minus, in this particular case, 4 factorial ways you have to neglect, because these 4 factorial ways are ways of forming 4-digit numbers, right? So those numbers start with 0, right? So 5 factorial. So it is nothing but, so 5 into 4 into 3 into 2 into 1 minus 4 into 3 into 2 into 1. So simplify it. It is 12 into 24 into 5 is, yes, 220. 24 into 5 is 220 minus 4 into 3, 12 into 2, 24. Right? Right? It is 120, sorry. 24 into 5 is 120. So therefore it is 96. Right? Total number of forming 5-digit number without 3. When 3 is excluded. Right? When 0 is excluded, it is 5 factorial. 5 factorial is nothing but 120. Right? 120. Therefore, total number of ways of forming 5-digit number. Right? Therefore, total ways of forming 5-digit number is, without 3 there are 120, or without 0, yes, without 0 there are 120 ways of forming 5-digit number, and without 3 there are 96 ways of forming 5-digit number. Together it is 216 ways, right? So option C is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app to practice such questions on permutations and combinations. Question 34. The sides AB, BC, CA of a triangle ABC have 3, 5 and 6 interior points respectively on them. The number of triangles that can be constructed using these points as vertices is given by. So students, let us consider a triangle ABC. Triangle ABC. Here the side AB has 3 interior points. So we have 3 interior points on AB and 5 interior points on BC and 6 interior points on AC. Right? Here the question is number of triangles that can be constructed using these points as vertices. So this is very important. You should not include A, B, C points here as vertices. Should consider only these points, 3 points, 5 points and 6 points. So totally there are 14 points. Right? Total points are 3 plus 6 plus 5. There are 14 points. Right? So using these points, you have to construct a triangle, or you have to form triangles. How many triangles can be formed? So for example, like this, right? Consider 2 points from one line like this and another point on another line. You can form a triangle. Consider 1 point from AB, another point from BC, right? And one more point from AC, you can form a triangle. Like this, how many triangles can be formed, right? You have to calculate now, right? For that, here in general case, we'll consider when 14 points are given, right? On a plane, let us consider 14 points which are non-collinear. Non-collinear. So we have taken 6 plus 2, 8, 9, 10, 11, 12, 13 and 14. These 14 points are non-collinear points. They are not collinear. Non-collinear means points which are not in the same line, right? So in such a case, you can form many triangles. So number of triangles can be formed is equal to, so number of triangles can be formed is equal to 14C3. Why it is 14C3? Because we have to pick 3 points, right? 3 points randomly out of 14 points. Because to form a triangle, we need 3 points, right? Therefore, it is 14C3, right? In general case, when points are non-collinear. But here in the given question, 3 points are collinear, and on BC 5 points are collinear, and 6 points are collinear on AC, right? These are collinear points, right? Therefore, you cannot take 14C3 as total number of triangles can be formed out of 14 points. Because, so if you consider first 3 points on AB, of course, there are 3 points, but you cannot form a triangle here, right? Therefore, first let us consider number of triangles that cannot be formed with non-collinear points. With the collinear points, not non-collinear points. Here in first case, we have taken number of triangles can be formed with non-collinear points, right? Which is 14C3. 14C3 is nothing but 14 factorial divided by 3 factorial into 14 minus 3 factorial. We are using the formula factorial n divided by r factorial into n minus r factorial, right? So 14 factorial is 14 into 13 into 12 into 11 factorial, and it continues up to 1, right? Therefore, I'll stop here only, up to 11 factorial by 3 factorial into 11 factorial. 14 minus 3 is 11. Therefore, we can cancel 11 factorial, 11 factorial. And we have 3 factorial is nothing but 6, right? So, 6 into 2 is 12. Therefore, we have 14 into 13 into 2. So, 14 into 13 into 2. So you will get 364, right? So we can form 364 triangles with non-collinear points. But in this particular case, there are collinear points, right? Therefore, we'll consider number of triangles which cannot be formed with collinear points, right? Number of triangles which cannot be formed with collinear points is equal to on AB we have 3 points. Therefore, we have to pick 3 out of 3, right? Therefore, 3C3 points, 3C3 triangles, right? So 3C3 triangles cannot be formed on AB or with collinear points, right? Plus, on BC we have 5 points, collinear points. So you have to pick 3 points. Therefore, 5C3 number of triangles cannot be formed, right? Plus, there are 6 points on AC. So 6C3 triangles cannot be formed. Since 3C3 is 1, plus 5C3 is factorial 5 divided by 3 factorial into 5 minus 3 factorial is 2 factorial, plus 6 factorial by 3 factorial into 6 minus 3 factorial is 3 factorial. So simplify it. So 1 plus, we are just adding these number of triangles which cannot be formed, right? So 1 plus, so 5 factorial is nothing but 5 into 4 into 3 factorial by 3 factorial into 2 factorial is 2 itself. Plus, in 6 factorial, we'll consider 6 into 5 into 4, and we'll consider 3 into 2 into 1 as 3 factorial by 3 factorial into another 3 factorial, we'll consider it as 6. So that we can cancel 1 3 factorial, both from numerator and denominator. And here also we'll cancel 3 factorial. And we have 1 plus 5 into 2, 10. And we can cancel 6 and 6 here. So 5 into 4, 20. Therefore, 31 triangles cannot be formed. these many triangles cannot be formed with collinear points, right? So in general case, so out of 14 points, we can form 364. In that 31 triangles cannot be formed. These cannot be formed. Therefore, total triangles can be formed is equal to 364 minus 31, which is nothing but 333, right? 333 triangles can be formed, right? Option B is the right answer, right? In ideal case, when points are non-collinear, 364, option A is the right answer. In this particular case, since there are collinear points on all the three sides, right? So we have to subtract number of triangles cannot be formed with collinear points, right? So which are 31 triangles, right? Therefore, so we have option B as the right answer. Question number 35. There are 60 greeting cards and 60 envelopes, both marked 1 to 60. The number of ways in which the greeting cards can be put in the envelopes so that exactly one of them is put in a wrong envelope is. So students will consider 60 greeting cards. So card 1, card 2, right? So card 3, so on up to card 60. There are 60 greeting cards, right? And 60 envelopes. We'll consider 60 envelopes. So envelope 1, envelope 2, so on up to envelope 60. Envelope 60, right? So you can consider card 1 in second envelope also. You can put card 1 in first envelope also. You can put in card envelope 60 also, right? So it is given that so the greeting cards can be put in the envelope so that exactly one of them is put in the wrong envelope. So somewhere in the middle, say for example in envelope number 43, right? So the card is wrongly placed in that particular envelope, right? Therefore, so here 59, there are 59 ways of putting each card in envelopes, right? So out of 60 envelopes, so in 59 ways, correctly you can put that particular card, right? So there are 59 ways of putting each card in the envelope, and that plus one way is wrong. So in the wrong envelope, the card can be put, right? So totally there are 60 cards, right? 60 cards. So therefore, so if for each card there are 59 ways, so for the second card also there are 59 ways, plus for the third card also there are 59 ways. For the fourth card there are 59 ways. So up to the 60th card there are 59 ways, right? So up to 60. So there are 60 cards into 59 ways, right? Totally, there are 60 into 59 ways. It is nothing but if n is considered as the total number of cards, so n into n minus 1, so gives number of ways. Number of ways. Why it is n minus 1? Because in one of the envelopes, the given card is put in wrong way, right? So it is wrong card or wrong envelope for that particular card. Therefore, it is n minus 1. So 60 into 59. What's the value of 60 into 59? You will get 3,540 ways. In 3,540 ways, you can put these cards in that particular envelopes, 60 envelopes, so that the condition is one of them is put in wrong envelope, right? So option C is the right answer. Question number 36. The number of divisors of 9,600 including 1 and 9,600 are. So here students, we need to find the number of divisors of the given number. For that, we are going to take the factors of 9600, right? So how to find the factors? By division method, right? So we start with the least number. 2 into 48, right, is 96. Then 2 into 24 is 48, 0, 0. Then 2 into 12 is 24. 2 into 600. Then 2 into 300. Then 2 into 150. Then 2 into 75. So in 75 is divisible by 3. Next number to 2 is 3. So 3 into 25. Then 25 is now divisible by 3. So 5 into 5 and 5 into 1. Right? So here 9600 can be written as 2 raised to 7 into 3 raised to 1 into 5 raised to 2. Here 2 is repeated 7 times, right? So these are called factors of 9600. When it comes to the divisors, right? So these divisors are not only factors, they are the product of factors also, right? So divisors are nothing but the factors of the given number and also the product of factors. So factor into factor. So here you can consider 3 into 2. 6 is also divisor of 9600. 5 into 5, 25 is also divisor. Then you can consider 2 into 2 into 2. 8 is also divisor into 2. 16 is also divisor, right? Therefore, in so many ways you can find, or number of ways in which the divisors can be written, right? So in this particular question, you can name it as number of ways, right? Therefore, so number of divisors of 9600 is equal to, these divisors are, so including 1 and 9600, so the number of divisors are, so exponent of 2 raised to 7 is 7. Consider this exponent, right? Plus 1, add 1 to that, into second exponent is 1, 3 raised to 1, plus 1, into third exponent is 2, plus 1, right? Here 7, 1 and 2 are exponents, right? Therefore, how many times the factors are repeated, right? These numbers are nothing but how many times the factors are repeated are called the exponents. So 7 plus 1 is 8 into 2 into 3. So which is 16 into 3 is 48. Therefore, there are 48 divisors of 9600, right? So by division method, we can get only 7 plus 1 plus 2. So there are 8 plus 2, 10 factors of 9600. But divisors are different, right? So they are the factors as well as they are the product of factors. Therefore, totally we can get 48 factors of 9600, right? Including 1 and 9600. Therefore, option C is the right answer. Question 37. Rahul has 12 shirts and 5 trousers. If one of the shirt and trouser has to be chosen, in how many ways can this be done? Very easy question, students. So there are 12 shirts and 5 trousers, right? 5 trousers. So one of the shirt and one of the trousers. So these have to be chosen, right? We have to choose one shirt out of 12 shirts, right? So choose one trouser out of 5 trousers. So in how many ways this can be done, right? So it is nothing but 12C1, right? We have to choose one shirt out of 12 shirts. It's nothing but 12C1 ways. In 12C1 ways, we can choose one shirt out of 12 shirts into, so you have to choose one trouser out of 5 trousers. So in 5C1 ways, we can choose one trouser out of 5 trousers, right? So which gives number of ways in which one shirt and one trouser can be chosen, right? Is equal to 12C1 is nothing but 12. right? It is factorial 12 divided by 1 factorial into 12 minus 1, which is 11 factorial. Here 11 factorial and 11 factorial will get cancelled. We have 12, right? And 5c1 is 5, right? It is nothing but 5 factorial divided by 1 factorial into 4 factorial. 5 minus 1 factorial is nothing but 4 factorial. Therefore, we have 5 into 12. So in 60 ways, we can choose one shirt and one trouser out of 12 shirts and 5 trousers, right? So in 60 ways, option C is the right answer. So here the trick is you have to take the product of these two ways, 12 ways and 5 ways, right? You should not add these ways, you should take the product, right? Therefore, option C is the right answer. Question 38. In an examination, there are 3 multiple choice questions and each question has 4 choices. The number of ways in which a student can fail to get all the answers correct is. So students, there are 3 multiple choice questions. Question 1, question 2 and question 3. Right? So each question has 4 choices. 1, 2, 3, 4 choices. Right? So each question has 4 choices. Question 3 also has 4 choices, right? So here we need to find the answer, that number of ways in which a student can fail to get all the answers correct. Here, the number of ways in which a student can get all the answers correct is only one way. If option 2 is correct here in question 1, option 3 is correct, option 1 is correct in question 3, right? In this order, there is only one way to get correct answer, right? And number of ways of answering these questions are many, right? So what are the number of ways of answering the questions? So we'll consider minus number of ways of getting correct answer, which is only one. So minus 1 gives number of ways of getting wrong answers, right? Which is nothing but the meaning of the question is number of ways in which the student can fail to get all the answers correct, which is nothing but number of ways of getting the wrong answers, right? So either first, so there are many ways. So for example, either first answer is wrong and the remaining two are correct, or second answer is wrong and the other two, first and second answers are correct, or all the answers are wrong, or one of the answers is wrong, right? There are many ways to get wrong answers. So how many ways are there to get wrong answers, right? So that's what the question is. Here we'll consider number of ways of answering the question. Number of ways of answering the question. Answering the questions is equal to, so for example, for question 1, there are 4 ways to answer question 1, right? So you can pick one, option 2, option 3 and option 4. There are 4 ways, right? Along with question 1, you have to answer question 2 also, right? So if you pick question option 1 as the answer, for question 2, you have to pick some other option, right? Option B or option 1 itself, right? So for question 3, if you have picked option 3, right? So for each question, for each way, right? For the remaining questions, there are many ways. Therefore, so the product of number of ways for each question, so 4 ways for each question into 4 ways for next question into 4 ways for the third question, right, is equal to the product of number of ways for each question is equal to 64 ways. There are 64 ways of answering the 3 questions, right? So out of 64, only one way of answering is correct, right? There is only one answer for each question. Therefore, number of ways of answering, answering the correct answer. Number of ways of answering the correct answer. For first question, there is only one way, right? So there is only one answer, correct answer. Therefore, there is one way of answering first question. Into one way. There is only one way to answer the correct answer. So into one way for the third question. So 1 into 1 into 1. So it is 1. Right? Therefore, come back to the question, number of ways in which student can fail to get all the answers correct. So that means number of ways in which student can answer wrongly, at least one wrong answer, right? Therefore, number of ways of getting wrong answers. Getting wrong answers. So it is equal to, so total ways of getting the answers minus number of ways of getting correct answer. So it is only 1. Therefore, 63. There are 63 ways of getting wrong answers, right? If one answer is wrong, then also so it includes in 63 ways, right? Therefore, option D is the right answer. Question 39. In a certain city, all the telephone numbers have 6 digits. The first 2 digits always being 41 or 42 or 46 or 62 or 64. The number of telephone numbers having all the 6 digits distinct is. Here students, so there are 6 digits in a telephone number, right? 6 digits. So in that first 2 digits have already been given. Right? So we'll consider first 2 digits, all the digits. So 41 or 42 or 46 or 62 or 64. Right? Therefore, there are 5 ways of writing first 2 digits. Right? So 41 or 42 or the remaining numbers. 5 ways. There are 5 ways of selecting first 2 digits. Right? So what are the remaining digits? Remaining digits. So out of 6 telephone numbers, so telephone numbers have 6 digits, right? So 2 digits have already been given, right? So in that there are 5 ways. So the remaining digits are 4 digits. So in that, so how to choose these 4 digits? So while choosing the telephone number, so the numbers range from 0 to 9. Right? So in between 0 and 9, there are 1, 2, 3, 4, 5, 6, 7, and 8. Right? So in each case, if you choose 41 as the first 2 digits, right? And the remaining digits are 0, then 2, 3, 5, 6, 7, 8, and 9. So the remaining digits are 8. So out of 8, you have to choose 4 digits. Choose 4 digits. Right? So out of 8, you have to choose 4 digits. So in the second case also, so if the number starts with 42, the remaining digits are 8 here. Right? So if you choose from 0 to 9, so avoid 4 and 2. The remaining digits are 8. Out of 8, choose 4 digits. Right? So for 46 also, next number, if it starts with 46, the remaining digits are 8. So you have to choose 4 digits. Right? Therefore, number of ways of choosing these 4 digits. Number of ways of choosing 4 digits is equal to, so out of 8, we have to choose 4 digits. Therefore, it is 8p4. So it is based on permutation. So in how many ways these numbers can be arranged is nothing but permutation. Right? So arrangement of 4 numbers out of 8 is nothing but 8p4. Right? So come back to the question. So number of telephone numbers having all the 6 digits distinct. Distinct means no number should be repeated. Right? Number should not be repeated. Should not be repeated. In 6-digit phone number, no number should be repeated. That is called distinct. Right? So here there are 5 ways of writing first 2 digits into 8p4 ways of writing the remaining 4 digits, right? Therefore, total ways of writing 6 digits phone number or telephonic number is equal to, so 5 ways of writing first 2 numbers into 8p4 ways of writing last 4 numbers, right? It is 5 into 8p4 is factorial 8 divided by 8 minus 4 factorial, which is nothing but 4 factorial. So 5 into, so 8 factorial is 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial. So we can cancel 4 factorial and 4 factorial. Now simplify it, right? So 8 into 7 into, we'll consider. So 8 into 7 into 6 into 5 into 5, right? So 8,400. So you can get 8,400 telephonic numbers, right? 6-digit telephone numbers, right? So having the first digits as 41 or 42 or 46 or 62 or 64 in the remaining digits, so you can arrange the four digits in 8p4 ways, right? Totally it is 8,400 ways. So option C is the right answer. Question number 40. In how many ways can 2 children be selected in a class of 25 students to represent the class? So here the meaning of the question is, out of 25 students, you have to choose only 2 students, right? Choose 2 students. So which means 25 C2 ways. In 25 C2 ways, so you can select 2 students out of 25, right? So 25 C2 is nothing but factorial 25 divided by factorial 2 into 25 minus 2 factorial. We are using the formula NCR is equal to factorial n divided by r factorial into factorial n minus r, right? So simplify it. 25 into 24 into, so 23 factorial. So it continues up to 2 into 1. Therefore, I am taking 23 factorial divided by 2 factorial is 2 into 25 minus 2 is 23 factorial. So we can cancel 23 factorial and 23 factorial, and 2 into 12 is 24. Right? So 25 into 12 is 300. Therefore, there are 3 ways of selecting 2 children. Right? 300, not 3. There are 300 ways of selecting 2 students out of 25. Right? Out of 25 students. Right? Therefore, option C is the right answer. Right? Whenever the question is given in such a way, so choosing some number out of some number, right? So this out of means the value of n and how many students have to be chosen. So how many students we need to choose here? So which is nothing but r. Therefore, it is NCR. Right? Therefore, for the given question, option C is the right answer. With this, I am completing this paper, students. So all these questions are taken from the previous year question papers. If you want to practice all the questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you a very best of luck for your future exams.